All right, we've got Attila Torok. Hey, Attila.
Hey, hello.
So give us a little background on yourself.
So I'm a London-based effect artist. I had worked mainly at Double Negative and ILM in London, and most of my time I spent at ILM when they opened. And since that, I got into tool development. So I was responsible at ILM for our particle simulation pipeline. I was working on our deformable and tearable deformable setups, and also Pyro and Pyro solvers and so on. And this is how I really got into tool development, really, next to Shotworks.
Right on. So what's today's presentation going to be about?
So today's presentation is about the work I've been doing for SideFX in the past year, which is basically creating tools to make sexy explosions. So it will involve a bit of attribute manipulation, which I find very important that we develop and give the user a bit more control over, which is very important, not just Pyro, but generally working with Houdini. And then we will talk about then connecting that to Pyro sourcing with the new burst tools, which will ignite the explosions. Then we will make trails out of the explosions, and I will show you how to set up different type of situations. Then I will show two examples of a fireball and an explosion that is like, call it a side explosion that could like burst out from the side of a building. And with that, we will looking at like shading and what are the new features, what is different. And in the meantime, I will share some of the things and some of the tips and tricks, what I've been used to create the marketing materials you all have been seeing already.
Fantastic. Well, let's get started.
All right, so let's jump right into the presentation. So the main things we're going to talk about are attribute modification. So this is something to do with Pyro sourcing. Then the actual Pyro sourcing, where we introduce two workflows. So this is one is the burst workflow, which is like the core of the explosion. This is the one which ignites the explosion, and the trail workflow, which with this you can create trails coming out from the explosion from this burst. And there is a way to combine bursts and trails and create a more robust, a more complex setup for explosions. So if we have a look at them in practical use, so here you see all of these little bursts coming out, and each of these bursts emit a set of trails with them. So this is the thing which this burst and trail workflow will allow you to do. On a side note, this is not part of the presentation, but if you are interested in making something similar, there are two additional elements in this explosion. So one is the constant sourcing from the bottom of the screen. So there are points scattered on ground which constantly emit fire and smoke into the simulation. So this is something I just did additionally, and the other thing is to make the explosion look more complex is this white smoke. So if you looking at references, you will notice that explosions are not just like the big fireball and whatever suit they create, but you will see white smoke, you will see black smoke on the other side. So there is a lot more interest going on in an explosion, and this is what I tried to create here. So this is basically just the white smoke is just a secondary simulation advected by the main simulation mostly, and shaded as white smoke with the scatter phase set to something like -0.030 -0.04 to give this a more lighter kind of smoke, which differs from the main smoke. Then here actually we can have a look at the bursts and the trails and how they combine together, so you might have a better overview how they relate to each other. Then after all of this sourcing, we will talk about simulation and shading. So shading in like what has changed in 18.5 and how you can make your explosion looking really nice. And simulation wise, we will be looking at two examples. One is this fireball, which is pretty much like the shelf tool fireball, but couple of additional little trick which I want to show you how to do. And the other one is the side explosion. Well, I call it side explosion because like this is something that could like burst out from the side of a building. Here you see a couple of shading techniques. For example, in this one I left the like you will see some bit of a like fire left over in the smoke, and in this one, for example, you will see these tendrily details, like how the smoke kind of forms the soot from the fire, which is something that you can notice on real explosion references. So attribute modification for 18.5 we have updated the attribute noise node, and we have created a new like family of nodes, the attribute adjust nodes. So we have now adjust float, adjust integer, and adjust vector nodes. So why do we need them? And what we wanted is to give more functionality for each attribute type. So you might need different controls to modify vector attribute than modifying, let's say, an integer attribute. And also we wanted to give more functionalities to control each of these attribute types. So if we have a look at the attribute adjust float node, for example, here you see that you can adjust the value with a constant, a uniform value across with all elements across the geometry. So but also the node provides way to do basic compositing, so basic attribute compositing, so you can combine two attributes together now. But one of the main part of this attribute adjust float node is randomization. So you can specify a range in which you will get random values. You are also able to use step size, which will run the values to integers. And again, you can set ranges in various ways. One of the most important one is specific values, in which you will see here that I can create even not continuous ranges with different step sizes. So for example, it's very handy if you want let's say attribute like start frame, and you have certain ranges in mind you want to distribute. So for example, here what I'm saying is I want values between 1 to 3 with a step size of 1, but I want values between 5 to 9 with a step size of 0.25. And the nice thing about this is that now all of these values in the range are distributed based on random distribution, but you can also set it to noise, so the same values still apply, but now you applying it based on a noise pattern. What we also did is we simplified parameters like element size, where now you have only one single parameter control, and if you want to access the per component control, you have a nice button at the end of the parameter to do that. And we have simplified the warping controls a bit, so it's much easier to create interesting looking patterns as well. And then going on, we have another new thing introduced now in the attribute adjust float node, which is unit conversion. So the original idea is coming from the fact that let's say attributes like life attributes are in seconds in Houdini. So a value of 1 means your particle is gonna live for 1 second. But what if you want to make your particles live exactly for 5 frames? what is the value for that? It's something like 0.2 whatever, like you would not necessarily know this, so before you would have to create expressions such as this one to kind of get the right values in seconds. But now attribute-adjust float node is able to do this unit conversion for you. So if I wanna do this example I just told you, I would set the value here to 5. That way, and I can set the unit settings to duration, and I can say that my attributes is gonna be in the unit of seconds, but my constant value is gonna be in the unit of frames. So now the node will know that the value of 5 will actually have to be converted into seconds. And the other thing we tried to do, and you might already realize that we tried to really unify the interfaces for all of these nodes. So if you have a quick look at it, you will see that the noise pattern, the general tab interface, like all of this, we tried to match as much as possible for each of these nodes. So that if you, let's say, starting to use one of the nodes, it's much easier to get used to all other nodes. Okay, so Pyro sourcing and the burst workflow. So we have a new node, Pyro burst source node, and this node generates animated points in random shapes, and you can use this as, like, you can convert them to source volumes for Pyro. So if we have a look at an example, this is the node where you can set initial size, direction, you can make it as grand explosion or make it more atmospheric explosion, and then you got the seed control. And as I said, these are animated bursts, so that you will see that they are animated over time to an expanded size. And the third tab is the burst components, where you see where all of these color points are created. So there is one set of points created for burn and one set of points created for temperature, and these points corresponds to the volumes needed for pyro, temperature, burn, etc. Then I wanna have a quick look at the quick setup menu. So this is something we have introduced for the Pyro tools in 18.5. So these menus are like not really presets, but they generate smaller node networks either before or after the node. And these set of nodes will help you, it can help you setting up this node or can help you go on the next task you would need to do. So for example, here I'm using the single input point, which will put down an add node before the node, so therefore I can just place the burst where I want in location in space. Then this one is the source volume quick setup element. So this way all of the burst components you create will be connected and automatically updated with the volume rasterize attribute, so you never have to type manually the attributes you want to rasterize. Let's go on to the next step, single burst. So let's see how to control source values and how to do some overrides for the burst. So in this one you will see that I have a burn parameter, and I can, if I just go back quickly, I can enable scaling along the trailing of the burst. So all of the burn values now, at the tip they are much lower than at the center of the burst. Then you have a basic noising functionality, so you can add noise to the burst. And what the cool thing is here is that now I have enabled both burn and temperature, and I can enable the seed burst override. So now I will have different seeds for each of these burst components, making the sourcing even more complex and varying, which could give more interesting results. And here I'm just playing with the start frame override actually. So I can even override the start frame for all the temperature or burn components, giving you even more control over the sourcing. And I'm just here adding density here and just doing the same, enabling a seed override, and this is the kind of burst I'm getting after all of these modifications. Then let's level up again for even more complex explosion sourcing. So all of these examples you have seen only use a single input point, but you can create multiple input points, and there is a way to randomize, to give even more randomization for all of these bursts. So looking at this example, I have an add node here, and then which creates a single point, but I'm replicating it and I'm making 3 points out of it and plugging that into the Pyro burst source node. Now I have 3 bursts like coming out exactly at the same time. Now we have a menu here introduced next to many of these parameters, which controls how these start frame values are assigned. So what you will see here is the default is set uniform, which will use whatever parameter value you set on the interface. But we provide a simple interface to vary the values very quickly on the interface. For that, I'm just setting it to set varying, and you will notice the additional parameters. And now basically I'm just modifying the start frame attribute per incoming point a bit to give it more variations. So, and I can also do the same with burst size as well. So you see that the power of this is, it's really great that you can just very easily create multiple bursts even for one single explosion, and even you can use multiple points for one single explosion, because that gives a much more interesting looking explosion. And then there is another way you can randomize the values per incoming point, and this is of course if you create the attribute values before the node, and each of these parameters are corresponding to so each of the parameters on the Pyro burst source node corresponds to an attribute, and if that attribute exists, you have to set this menu to pick up those attributes or that attribute. So here I just clicked on the randomize icon here, which will put down an attribute adjust node. So here I'm just gonna set the start frame attribute, and you will see now I'm using that attribute. So you will see that each of these birds just popping out one after the other. And then what I can also do is to randomize the source value per incoming point. So here I just created a burn attribute, an attribute adjust node for burn, so that I can randomize the burn value for each of these bursts. So now on default I'm just increasing the value from 1 to something higher, but I can also randomize the values per burst. And the really nice thing is that if these values, like burn value is 0 on some of these points, then there will be no corresponding burst component created for that node, for that burst, sorry. So that this way you will really get true randomization for this burst. Let's look at the shell workflow then. One of the node you can use is the PyroShell path node. So this generates the path for the projectiles that fly out from the explosion or from the burst, and these paths are generated without an actual simulation. So there is no pop simulation involved in this, which means that these are very fast to generate and very fast to iterate over certain look and certain, you know, properties of this path. But as a drawback, that means they cannot handle complex collisions, even though we introduce some sort of basic collision detection that could help you with most cases. So if we look at the node, this is the PyroChip path node, and you can see all the paths generated from a single burst. So you can change the direction of this path. You can change the number of shells, for example, of course. Here I'm just making more path and just prune it by a noise, so it gives variation on all sides. Then if you want some more specific control over how they directed, you can use the spread angle to have the trails coming out from all across the unit sphere, or you can make them fly out only on one side of the explosion, such as this one. So you have really great control over how these trails are controlled. You have options to change or randomize the initial launch speed of these projectiles, which will make them fly up more stronger. Then of course you have drag, mass options there, and you can change how long these projectiles live, and just some basic collision detection options, so you can clip below a certain height. And with the next one, with this next one, I just want to show you what Emily did for her project here, is that she used this basic collision detection, which you find on this node, to kind of make the trails bounce with a box, and you get these nice trails, like, you know, bouncing off. And for most cases, I think this provides a very good control. Then, yeah, so these are only the paths, but the question is, you can ask, so how do we get the actual points? Like, how do we get animated points out of these curves and use them as the pyro source? So the answer to that is the pyro trail source node, which is, I consider it as the sister node of the pyro burst source node. So the input is the trail path, which generated by the pyro trail path node, and this node, as you see here, will take those paths and just generates all the trail points onto each of these projectile paths, and these are all animated now, and you can use them for pyro sourcing. There are, as you see, controls over the source value, over the length. You can use some of these options to, for example, just convert them to volume and use them straight out to render them without actually putting it into any pyro simulation, which could be useful for explosions very far in the background, where you do not really need these trails to be actually part of the simulation. Then what you can do still is apply some noise on these trails, so you can make them, you know, a bit more irregular as they fly to the path. And here I'm just showing one of these other tricks which most of these examples we did use, is I'm just making a temperature source additionally, and I'm changing the length scale of it to very small, so that they only present at the tip of these trails. In the pyro simulation, I'm just only sourcing the density, for example, but not this temperature. And these temperature values are only combined before the shading and used only to make the tip of the explosion glow a bit. So far what I have shown is just a very basic way and the most quickest way to create trails. But there's a lot more going on in the background. So let's look into that. So the pyro scatter from burst node is a very special point replicate node for pyro, and its whole purpose is to just scatter points around the input points, and assigns velocity attribute and start frame attribute, and you can use this to generate your projectiles. So, and these projectiles can be generated with the ballistic path node. So it expects points with velocity attributes, and it generates these curves with an additional time point attribute. And this is very, very important. the extract point from curve node then can take these curves, and using this time attribute, it can sort of extract the position of the projectiles from the curve at a given time. So let's look at it in practice. So here you see that I have a pyroscatter from burst node creating points. Then the ballistic path node is templated so that I'm showing all the pyro trails created here. But then I'm taking the extract point from curve node and I'm just playing the timeline, and you can see that I'm using the time attribute and cut it by the current time, and that gives me all of these animated points across the trails, therefore giving me the position of the projectile at the current time. But the pyroscatter from burst node, the generated points from it can be used for many other things. So for example, they could be starting point for spark simulations or custom trail setups, but again, custom trail setups where you want to use particle simulation to generate your trails. So here, for example, again, I'm just showing you the trails you would get from a ballistic path node. But on the pyroscatter from burst node, you can use the quick setup menu, and by selecting the particle simulation option, you will be getting a whole set of network that will use the points from the pyroscatter from burst node, and these will be used then for can be used for custom particle simulation. So this is all set up for you. Then here you can also choose simulated trails. So this is very much the same network, but additionally we will have a ballistic path from simulation network here, which actually, as you see, generates trail paths very much matching the trails given by the ballistic path node, so that if you need something very specific collisions or something very specific things that you can only do with particle simulation, you still have the option to do very matching ballistic paths using the simulation way. And here I'm just putting down a pyrotrail source node to demonstrate that it's all also working using the pyrotrail source node. There is one more thing I want to mention, and this is targeted launch for ballistic path node. So here I'm just putting down a circle, scattered some points on this circle, and storing this point location in a target P attribute, then moving everything back to the origin. With the ballistic path node, I can select launch method targeted, and with the targeting method, I can set a certain constraint. So what I'm doing here is I'm saying that every projectile should end at the target position or should aim to hit the target position, but I can give certain constraint, like let's say while it's hitting the target position, the projectile should be at a certain, or should also reach a certain height, or should live for certain seconds. So this gives you a lot more interesting control over the projectiles. And for example, here I'm just randomizing the target position as well. So you can get really customized pyrotrail path for your explosions. So let's do something a bit more exciting then, and let's start to combine trails and bursts. So you can do it a couple of ways, and one of the ways is the single burst way. So one single burst for each explosion. And here I'm creating just a line with 5 points, and I'm assigning start frame attribute randomly to these points, and with the pyro burst source node, I just pick up this attribute and created randomization how they popping up. Then I do the same with the pyrotrail path node as well. And now if I display the pyrotrail source and the pyro burst source, you will see that the bursts and the trails are all organized, well, they are all synchronized actually together based on a common start frame attribute. And here I'm just also showing that I customized the launch speed of these trail paths per incoming explosion, so that I can make the trails coming out from one explosion much larger than the others, for example. So this can give you a lot more control over the consecutive explosion look. And then here I'm just again displaying them all, the trails. Then let's again do like step up a bit, and let's do the next level, which is like the multiple bursts per explosion. So here I have a very similar setup, and I again creating start frame attribute here per each point, and then I'm just replicating points on each of these points, 3 actually to be exact, and creating explosion ID and burst ID. And the main idea is here that I want to make every explosion, every of my 5 explosion explode at a different time, but I also want to make sure that every burst inside that explosion I also randomized a bit relative to the main start frame, or the main ignition frame really. So here I'm just showing you that the explosion ID is the same for each of these clusters, and then I'm using just an attribute adjustFloat to randomize the start frame attribute based on the burst ID, so they now got a bit of offset, which you can see, like this is the one before the shifting, and then this is after the second randomization. And now what you will see is that again each of these bursts are a bit offset to one another. And for the trails, again, what is important in this kind of setups is fusing the input points, because now I'm using 3 input points for the same explosion, which will generate a lot more trails than what you would need. And you can fuse the input points by an attribute, and here I'm using the explosion ID so that only one input point will generate trails for the given explosion. So this covers the most important aspect of pyro sourcing, and hopefully this brief introduction will help you to get started and give you some ideas what you can achieve with the tools. And then for the second part of this presentation, then let's talk about shading, and then we will looking at examples. What has changed shading wise, and one of the most important thing is to move away from the physical black body, and I put an angry fruit salad here because I know that some of you might not gonna like this, but it doesn't mean that physical black body has to be removed. It just, on most of the tools, this is not the default anymore, in favor of this nice pretty looking color ramp. So we have decided about this because my personal experience working with physical black body. So I find it very hard to control, and it's very easy to get this kind of what I would call a burned shrimp look. So you get this super bright yellow, super bright reds in it, and it just to me, my personal opinion is that it just does not gives realistic results, even though it should represent physically accurate coloring. And none of the explosion I seen in production and I said, wow, this explosion looks really sexy and amazing, none of those explosions were done using physical black body methods. And as I said, instead we went for this ramp which goes from black to the actual explosion color, which is this nice orange color in default, and this allows us to create nice looking explosion out of the box. And if you need to change the explosion color to, let's say, blue, you only have to change the color at the right side of the ramp to blue. And here, just to show all the different looks, so this is the top is the explosion viewed with physical black body coloring. Then the middle one is using the ramp and viewed from the PyroSoft solver. And this last one is also using the same ramp, but it's viewed through the PyroBake volume node, and it's also has this nice crunchy look enabled to it. So, and we will talk about it in a second. And just to show you, this is the side explosion. I will go through. This is the kind of coloring and look that you could get on default with this ramp. The other thing we tried to change for 18.5 is the use of the flame field for the shading. So now that physical black body, we're trying to move away from that. We no longer really need the flame field either to use this for shading. So yeah, you can consider it as one less field to export and worry about. So except one, all of our examples we have done for 18.5 are using only density and temperature for shading, even the bonfire. So I consider the flame field as just an additional field that helps you shape your simulation. It doesn't mean that on the PyroSolver tab you got the flame tab, and this allows for, as I said, additional controls like to add expansion through the flame field, or to add additional temperature and additional density through the flame field, which is all great, but this is not the secret, for example, to create good looking fire. As I said, you only need density, temperature, and some, nice turbulence controls. That's not said that, it's not useful. It's very, very useful. You just, it's important for you to know where and how to use it. So, for example, as I said, there was one exception, and this was Ian's project. So Ian was working on this firecracker project, and he was using both flame and temperature fields to shade this smoke plume. And the reason for this is because we were looking at references, and we were seeing this like big plume of smokes, and inside there you would see this kind of cluster of bursts like popping out, sometimes here, sometimes there, like very randomly at different places. And Ian was sourcing in density, of course, from the firecrackers, but also temperature everywhere where you got density. So that meant that we couldn't really just use temperature, because temperature is pretty much everywhere where density is. So Ian created this kind of localized flame sources randomly at certain locations, and these were sourced into as flames, and these field then were used to shade this kind of explosion burst in the smoke. And then also we were using the temperature field which was actually masked to kind of create this additional kind of rising flame components as well. The other important thing to mention is the ACES workflow. So all of the examples we have done, which you see on the right side, for example, were done using the ACES workflow. And if you install Houdini and you just open it up and you start to work with Pyro, what you will end up is basically the look on the left side. And to get from this to the right side, look, you have to install, or you have to set up ACES with Houdini. And yeah, please go to the documentation under the Pyro shading section. You will find information how to get going with ACES. And the other important thing is a good quality HDRI map. So, you can shade or light your explosions using area lights, but one of the easiest way is to just drop down an environment light and use a good quality HDRI map. And I'm saying good quality here because there is a big difference between HDRI maps, and the good quality one can give you really nice coloring into the on the smoke components of your explosions, and especially when used with absorption color, which I will talk about on the shader. I would like to talk about some of the changes I made on the Pyro solver for the content library explosions. So basically this is about parameters that usually good to animate. For example, time scale and buoyancy scale is something that I kind of tend to animate when I'm working on like a single explosion. So I'm pretty sure we are all familiar with the typical, okay, let's set up a couple of keyframes, but then as I scrub the timeline, the simulation trying to update, then I have to set the updating to manual mode, but then I also have to open up the animation curve editor. So it could be rather cumbersome to set up even a couple of keyframes. And the way I go about this is creating a couple of spare parameters. And here you can see that the time scale is driven based on an expression which is driven by a couple of parameters. So here what I'm saying is that at the start frame, my buoyancy scale should have the value of 1.75, but in the duration of 10 frames, this 1.75 should shrink down to a value of 1. So now instead of keyframes, I'm just using these parameters to control the animation aspect of the timescale parameter. And this has been introduced to timescale, buoyancy scale, and the turbulence strength on the shape tab. The other thing is the way I set up the look tab on the Pyro solver. So as I do not use physical blackbody, to me the default setup where the flame field is used for the fire intensity and the temperature is used for the fire color, this visualization kind of tells me nothing really. It's not useful for me. But what is useful for me is to just display the temperature or the flame over the density. So what I do is I use the same field. It could be temperature flame or flame field for both intensity and color. And I use the same flame range to clamp both intensity and the color. So that way, I can visualize temperature over the smoke, and then I can get a sense of my temperature field or my flame field separately, which I find much more useful also later to set up the scattering and the crunchy details. Now that I mentioned the flame intensity and color ranges, it is really important to know the maximum volume values to set up these ranges correctly. So I don't mean that you have to know these on every frame, but please make sure that you know the maximum values for density, temperature, flame, etc. on couple of the important frames that you would use for shading your explosion, because that could really help you to kind of nail down the look of the explosion. And you can find this information on the actual geometry as primitive attribute, and this is automatically created for you for, using the Pyro subsolver. After all of this, I think we are finally ready to look at the scene file for the fireball, which is in the content library. So here I use pretty much the default setting for the pyro burst source. I changed the duration a bit longer, and I made the temperature and the burn sources a bit larger than the actual temperature source. And then with the pyro solver, I'm just putting it somewhere where the simulation is a bit more advanced in time. And And what's important is to mention here is the density sourcing. So I'm using rather high value as a scale of 5 with the add operation. So this will create loads of high value density. And then what is important to mention here, yes, so because I'm using such high density values, I kind of wanted to make this example not to use the smoke emission based on the flame, but I input a bit of temperature based on the flame, and I'm driving a bit of expansion using the flame. The other important thing to mention is the disturbance. So I'm using a rather high disturbance with a speed field as the control field. So this is important to get the crunchy kind of details into the simulation, that the density fields is kind of nicely disturbed. And the speed field is just tells you how fast the fluid is moving actually. And this is calculated based on the checkbox on the simulation tab. So if you enable calculate speed field, then you can use the keyword speed into your control fields to control, for example, disturbance or turbulence. And then the other thing is the turbulence, which I mentioned. I'm using my custom animation controls to animate turbulence so that at the beginning it's a very high value of 5, and then in the duration of 10 frames it just shrinks down to 0.05. And I'm using a rather large swirl size for this turbulence. So the purpose of this turbulence is to just create some at the burst of the explosion where the explosion expands the most. I just want to tear up the kind of expansion a lot to create more interesting large kind of noises to break up the simulation. So that's why I'm kind of only using very strong turbulence just in the first couple of frames. And of course I'm using the density as kind of control field for that. And the other thing which is important to mention is all of these settings on the export tab. So if you enable these and you resample your velocity, and if you use 16-bit float, this will really help you to save this space on your caches up to, I don't know, you can reduce them up to only even 10-15% of your of what would be your cache on default. So what settings were used for the side explosion? Here you can see that I'm creating a sort of a multi-burst explosion. So as I said, even though it's a single explosion, I'm using multiple input points for generating multiple burst sources, which gives kind of the look of one single explosion. And again, here I change a couple of settings, for example, the direction parameter. And as you can see, I'm adding a bit of noise into the sourcing as well. And in this simulation, I do emit smoke into the simulation based on the flame, but here I decided not to use temperature. And the settings are pretty much the same as well. So the disturbance is also controlled by speed again, and also a rather large disturbance value I use. And also the turbulence is also very strong at the beginning, but reduced a lot over a period of 10 frames. So after the simulation, let's talk about finally the shading. So we have a new node, which is the PyroBake volume node. So this node, I think the best way to understand this node, if you consider this as a PyroLook node, so it's kind of same in functionality with the Pyro post-process node's look tab. So this node has all the options and parameters to control the look of your simulations. So you got the smoke tab to shade simple smoke elements. but if you want to work with fire and explosion, you got 3 separate emission components. So you got scatter, fire, and secondary fire, which each controls the emission component in its own way. With the PyroBake volume node, I tried to simplify the labeling, how volumes are assigned to the different emission aspects. So if you look at here the PyroPost process node and how it was set up previously, you will see that there are 2 sections. One is actually just simply labeled fire, but this actually controls the fire intensity. But then the other section is labeled as fire color, which is rightfully controls the color of the fire. But when I go back and see, so what are the volumes that are binding to this, I realize that the fire color, it's actually binded to a parameter which is called temperature, and the fire intensity section is binded to a parameter which is labeled flame. So it's rather kind of confusing which is responsible for what. And this is just gets exponentially confusing for me when I have to work with the Pyro shader, where again this kind of situation shows up again. And to kind of simplify this on the PyroBake volume node, I tried to create labels according intensity and color. So we got an intensity volume label, which is actually responsible for the intensity aspect of the fire. And then we got the color volume, which is actually responsible for the color section here. So hopefully this way it's much easier to find which volume controls which sections. And well, in this case now both of these volumes are controlled through temperature. On top of this, I tried to make sure that the interface for the PyroBake volume and the new Pyro shader are resembling each other. So you will see that the same tabbing in the same order, and also many of the parameters labeled the same. The only difference what you see here now on the smoke tab is coming from the fact that some of the features on the shader are like considered more sort of advanced controls that are currently not possible visualizing in the viewport. Therefore, these controls on the PyroBake volume are not available. To get all the nice crunchy looking details in the explosion, you also have to use the PyroBake volume node. So when the scattering is enabled on this node, a special volume is generated, which is called the scatter volume. And to generate this scatter volume, you actually have to use an existing input volume, which is on default the temperature. So this temperature volume then gets basically converted to the scatter volume. So if we look at an example, this is just, I'm just here enabling scattering. So here what you see now is basically just the temperature visualized, and I have a rather high intensity scale here. But then what's happening here is that I'm taking this temperature, and which is a float volume, and internally this node converting this float volume based on the source range to vector volume representing RGB colors based on the scatter color ramp. So and the end result is what you see in the viewport now. After this, if I enable the blurring, what you will see is that this generated color volume now it's blurred out and creating this really nice looking kind of internal scattering for the explosion. So after this, you can set the source range, and for example here I'm just saying that more of the temperature should contribute into the scattering, therefore making it brighter or creating more scattering inside. Then the last thing is demasking, and this is a very important part for the crunchy look. So what's happening is that we're using a masking volume which is on default the density. And basically what I'm saying here is whenever the density is lower than the combination of the mask center and the mask squid, we're gonna let the scattering shine through, the scattered volume to shine through. And wherever the density values are higher than this combination of mask center and mask width, there we will actually cut out the scattering and we will let the smoke through. And again, here I'm just changing the amount of scattering I want to apply to this explosion, so therefore creating completely different look and how the kind of fire kind of fades off in the explosion. The pyro bake volume automatically comes with a pyro shader inside of it, and this pyro shader is referencing all the parameters on the pyro bake volume node. So therefore trying to make sure that the look what you got in the viewport is matching the render look as close as possible. So for example, here I have the pyro bake volume and I just dive inside to access the shader, and you will see that you got all the parameters referencing the node, but you also, important to mention, that you got additional parameters on the shader that is not available on the pyro bake volume node. And this is because for example, what this use control volume does is it allows you to scale the smoke density with another volume such as temperature and kind of do this post operation in the shader. But unfortunately, operation like this is not supported by the volume visualization node, so therefore we cannot visualize this in the viewport. So there are a couple of controls like this for which you actually have to dive inside the shader, but it provides a better control on rendering. And also one other thing which is important to mention, the absorption color. Again, this is not available on the pyro bake volume node, but with this, if you're starting to change the color of the absorption color, then you will see that the smoke kind of changes color as the light scatters through the volume. So with this you can create a lot more realistic looking smoke effects. Then again, couple of other parameters. You also see that you got the scatter, the fire interfaces, and all of these are automatically linked up to the pyro bake volume node. Then the material, as I was pointing, it's the pyro bake volume has the assign material path, which actually points to the internal pyro shader. But to manage the shaders, you can go to the quick setup menu, and here what you can do is break material reference, and that will dereference all the parameters from the shader. And this is important because if you change the parameters on the pyro bake volume while you trying to do interactive render updates, it might take a bit of time to recook the volume every time for rendering. And by breaking the references to the material node, the geometry do not have to update, so your interactive render updates will be much faster. Of course, this means that your pyro bake volume settings might no longer match up with the settings used on your pyro shader. But then you can also create new materials using the quick setup menu, and you can choose where to create it. You can, for example, I just do it next to the pyro bake volume, and you see you create the same kind of linked shader setup. And of course I can break the material reference to this node, and then I just create one node inside the PyroBake volume. So, and then you see now a second material node is created there, and now that material is assigned to the node, and this is really nice. I find it really nice to kind of collect couple of pyro shaders inside the PyroBake volume node, and this really allowed me to kind of just copy one single PyroBake volume over a couple of different setups and easily get different pyro looks. So basically PyroBake volume kind of acts as a container for my different look dev setups. So as I said, the density or the smoke can be scaled on the pyro shader using a control volume, and on default again this is temperature, and this will allow us to do some super nice trick which were not possible before. And what you see here is the side explosion rendered on the left side without this the use of this control volume scale. But on the right side I enable this, and what this will allow after playing around with the values is that you can get this really nice tangerine looking smoke details detaching from the fire. And this is something again which you will see a lot on real explosion references, but before they were not possible to get to this kind of realistic looking details with previous shaders. And just again to show you here the couple of versions for the side explosion. Again here this is without the control volume, and then here I'm just on this one on top of the scattering I enable the fire component on the shader and on the PyroBake volume. So I'm getting and I had to balance it out a bit, but I'm getting this really nice kind of fainty kind of flame leftover in the smoke kind of effect. And then for the last one, this is with the enabled control volume, where I'm actually scaling the smoke density with the temperature, and you will see this really nice kind of tendrils detaching from the fire. As the last thing, I just want to show you the other option we introduced on the quick setup menu to help you set up rendering of your simulations as fast as possible. So here I'm just using the simple fireball as an example. I'm putting down the shelf tool example, and then on the PyroBake volume node, I'm just going and simulating a couple of frames first. Yeah, that should be enough. And then using the create lights and cameras option, I can say use this geometry as my render geometry, and I'm getting all the lights and camera set up. So what you should do is you set your viewport in the position where you want to render from, so that way the camera will be created exactly from that angle. And then also volume light and environment light will be set up for you automatically. And the top network with a mantra node that already has some image planes set it up for you, but these are disabled on default. And then you got some options to start and get going the rendering with a very low resolution render. To close the presentation, I would like to show you this really nice explosion done by Jeffy Matthew. So here you can see all of these components working together, the new shader, the trails, the bursts, and even he went a step further and he used the pyro burst source node to create the kind of shockwaves. And basically the secret here is that you just instance the pyro burst sources onto a circle, each pointing outwards, and when they are animated and expanding, and clip by the ground, they can, create the essence of kind of a ground shockwave expanding out from the explosion. So then that's it for this presentation, and there was a lot to cover in this session, and I hope that it's a good overview of what you can do, and it helps you get you going with all the tools introduced in 18.5 for Pyro, and I'm looking forward to see many great looking explosions, and yeah, thank you for watching.
All right, next up we've got Henry Dean. Hey, Henry, good to see you.
Hello, Chris. How you doing?
So give us a little background on yourself.
So I've been a freelance character artist and technical director for the last 7-8 years or so, and for 5-6 of those years I've been working exclusively with Houdini, and over the last nearly couple of years I've been happily working on the KineFX toolset, which we'll be looking at in this presentation.
Excellent. So what parts of that are you going to be covering in this one?
So the scope of the toolset is very, very broad. There won't be time to cover all aspects of it, but what I'm hoping to do is to cover some of the fundamental ideas and some of the philosophy behind the development of the tools and what the implications of that might be for everybody's future character work.
Excellent. Well, let's get started.
Thanks. Hello and welcome to this presentation on the KineFX framework new in Houdini 18.5. So the KineFX framework marks the first step on a journey to reimagining the rigging and animation workflow in Houdini. In this first iteration, we've got some really powerful tools for motion retargeting, and this was one of the original mandates of the toolset. As development continued, this expanded in scope and is now part of an ongoing project to encapsulate the whole of the character animation workflow. For the retargeting side, I'm not going to be touching too much on that explicitly, so Mithna and Bogdan will be coming back with talks later on that will deal expressly with these tools. For this presentation, I just wanted to have a little play, discuss some of the fundamental concepts, and give an idea of where you can take these tools in helping with your workflows. So on we go to the fundamental ideas behind the toolset. And the big one, of course, is that we're moving everything into the geometry context. And really, this is just a small part of the character rigging process that's being moved in to SOP. So blend shapes were always geometry. Anything that was driven by a curve or was adhering to a surface, all these kinds of constraints, they were also driven by geometry. And of course, the final deformation is geometry. So it was really only the bones or joints and the controls that the animator works with that lived outside of this space. So KineFX brings all of that into this same context. The next little note that I have here about the design of the tools is that world space is king. And this is a really important idea. The points in KineFX and the tools that operate on them, they very much view the input world transforms as being the ground truth. We don't want to change our input unless we explicitly say so. So any local space transformations are computed per operation, which gives us a huge amount of flexibility in doing things that would have been prohibitively difficult working at object level or with any kind of static scene graph. As a little example of this, I'll just jump over to Houdini. And here I've got a very simple retargeting setup that we'll be making use of later. For now, I just want to focus on the skeleton we have over here. It's being brought in by the FBX animation import node. As I scrub backwards and forwards, we can see the motion. Now, all we have on these points is a P attribute and a 3x3 matrix transform attribute. The decision to break the world space transform up into these two attributes is mainly driven by the fact that every point in Houdini has a position. The moment you create a point, it has a position. This is not an optional attribute. So to avoid any potential conflicts, putting things out of sync with a full matrix 4 transform attribute, we decided to keep these things separate and leave P to handle our world space translation, and everything else will be handled by the 3x3 matrix, so rotation, scale, and shear. And as we scrub through, we're seeing the animation. We've got no local transform attribute on these points. The moment that we want to do something in local space, however, well, then we need it. But the nodes themselves recompute this on the fly. And as a very trivial example of this, I'm just going to come and put some adjustments on the head. I'll just move it up and rotate it. And now as I scrub through, you can see that the rig pose has applied this as an edit on top of the incoming animation. To prove my point, I'm going to put a delete joint sort down, and I'm going to grab a whole bunch of points. I'll just grab all of these and delete them. If I come back to the rig pose and I bypass and unbypass this, you can see that the head is staying where it's put. So as the topology changes here, the rig pose updates the input local transform before it applies its own edits. So it's a very, very powerful idea, and one that gives you a huge amount of flexibility in the kind of operations that you can perform. So this is key. If I do this the other way round, we can see another important idea. I'll just clear my edits here, and I'm going to translate this off. So having operated on a subset of the points, we haven't lost anything. I haven't deleted anything that's persistent. We still have our original hierarchy. And should I want to then take those edits and reapply them to that full hierarchy, well, I'm only a node away from copying those transforms back over. You can see that this has collapsed down, and that's because, of course, by default, the skeleton blend works in local space. The local space of the abdomen here has very much changed. So if I toggle on the world space, you can see that we're copying over the world space transforms for any joints that exist on the right-hand side. And so now as I perform any edits, we can see that flow through and get reapplied to our full hierarchy. So very trivial example, but hopefully demonstrates some of the features behind this idea. So I'll just clean that up and let's jump back to our slide. The next important concept is the idea of a rig as an operation and a separation of concerns that comes with this. This isn't a new idea. It's a very common practice to rig using what we might call a shadow rig or a deformation rig that's a completely separate hierarchy to the control rig that an animator would interact with. And this helps pipelines keep a very clean rig for export. So especially important if you're working with game engines or anything like that, where we don't want the control hierarchy mixed in with the deformation hierarchy. It generally makes a mess of things. So it's very often a good practice anyway. And this is something that's very close to the heart of the networks that you'll see set up in KineFX going forward. We have this minimal set of joints responsible for the final deformation. How we drive those, well, we decide that over here. But we always just write back to this minimal set. So this enables us to stay organized and to keep a clean character for import and export. The next little note is just about the open architecture. The data model for the joints, the points, is very, very lightweight. The minimum attributes that are required are a 3x3 transform for the world space and a name. And the name attribute, whilst not explicitly necessary for lots of the operations, it's highly recommended that you do name points when working with the KineFX tools, and that the name should be unique per point. So the rig doctor node is one that can help you do this. There's an option to pick up the duplicate names and add a numerical suffix to them to ensure that we have unique names on the output. Of course, this open architecture, the fact that we now have access to the world space transforms at the very lowest level, is hugely powerful, but also puts a bit more of an onus on us to stay organized. So the KineFX tools that are shipped with 18.5 provide some ways of helping with this. There's something to be aware of, that when you go off-piste and start playing with these attributes directly, that you do have to stay organized and keep things clean. So, what do we have here? Revisiting a prototype. So a long time ago, I had a little play at just a little idea, really, of being able to draw out a bone chain, and this was working at object level, using a stroke sop as an input. And I did get something working, but there was a lot of Python involved, and we were also treading the slightly sketchy territory of creating objects dynamically and actually modifying our scene based upon a continuous input event, and this is already something that it can end up being brittle. So this was the little prototype that I tried to knock up at object level, and I thought it made a good use case to explore in KineFX. So let's see if we can recreate it in KineFX a little bit more easily. So I'm going to create a new geometry network, and I'm going to dive inside. Drop a strokes up to enable us to draw, and I'm just going to resample this into the number of joints that I want. So I'll pick the default 10 for now. The next thing that we're going to need is our transform attribute, as I just mentioned. So we'll initialize this using, again, another stock SOP node, which will create this 3x3 transform for us. Drop down the rig doctor, which we're simply going to ask it to initialize our missing names. There's one more option here which I haven't changed from the default, which I need to on the orient along curve, which is, instead of using an average of the edge directions for the tangent, I'll choose next edge. And now as we come back, we can see that we've got joints that are nicely aligned to their child. Okay, great. That's our joint chain made. Step number 2. Can we retrofit a spline to drive this with a spline IK? Well, let's have a go. I'm going to fit a NURBS curve to it. Currently, I'm creating quite a lot of points to conform to this shape. So let's pull that tolerance right up. And in fact, I think we might be... Yep, so this will force the creation of 4 control points. Now, because of the input shape that I've given it, it's having to do some pretty wild stuff. So let's start with a slightly simpler curve. Okay, there we go. Something a bit more sane as an input. We've got our 4 points. I'm going to transfer the transform information from the original chain. And I'm going to duplicate this rig doctor just to do the same thing and initialize some names. And of course, I should be going back and making these names a bit more sensible. So maybe something like spline joint as the prefix. And here I can have spline control as the prefix for these. Next job is just a little bit of stuff to make it a bit easier to identify these points. And then, of course, we want to be able to move these controls, so I'll put down the rig post. So the final step is to actually evaluate the IK. So I'll plug in our original created joint chain up here, and I'll add our controls on the second input. The VOP node that we're looking for is the curve solver here. And I just want to grab all of the points from the first input and all of the points from the second input and drive one with the other. To do this, I'll use the getPointTransforms VOP, which fetches a whole bunch of transforms based upon a group. So this is going to be our joints that we want to drive. I'll Alt-click drag to duplicate that, change this to the second input, and this will grab our controls. The last step is to actually write the solution back to our points. Okay, and you can see a little jump here if I right-click and untoggle display inputs. And now as I bypass and unbypass this, we can see the effect that our solve is having. And we are getting that loss of fidelity that we would expect when we're trying to fit a curve to this arbitrary joint chain. There's one thing I forgot to do, which is to make sure that our curve type matches the type of curve that we're creating on the right-hand side. And this, you won't see a difference here for now. However, if I want to get this to adhere more closely to the curve, so let's come back and we'll clear this out. And if I come back to one of my funky earlier shapes, we can have a look at our controls. You can see that because of the tolerance I've set, we've now got more control objects. And it's given us 6. So this might be a bit much to work with when we're actually solving the IK solution. So we can always create some parenting relationships that work for us better on these controls. As it is, we already have some, and if I display the links, we can see more clearly that because these points still exist on a primitive, we've got that hierarchical information there. In order to remove that, I'm going to use a humble add-sop, delete the geometry but keep the points, and we now have a bunch of points floating in world space that I can move individually. Now with this higher count of controls, these ones aren't feeling especially helpful here. So if I drop a reparent joints afterwards, I can just grab these ones and reparent them to the controls at the very end of the chain. And this now gives us slightly coarser control over this, so we've still got these main controls up here and all the rest of it. Now, of course, we've broken a little bit we've possibly introduced the brittleness here, in as much if our point count changes up here, these names won't exist. So, we've always got to look at how we've organized things. But this is just that bit. If I wanted to stick to our 4 controls, I can just increase the tolerance, and we'll get those 4 controls on our input. Okay, so that's that. That was the recreating that prototype that I really, really struggled with at object level. Back over here. Now, as I built that, I had a thought that I've definitely got 2 steps here. So being able to identify processes and split them up and reuse them for different things, this is something that really gets brought to the fore when we're working with these SOP level tools. So if I look at the network I just created, I had one step which was to build a joint chain. Then I had another step which was to fit a spline and create the controls, and then the final step was to actually run the solve. So the thought that I had was, well, if this is just a joint chain, then maybe we can pull that from somewhere else. So let's have a hop back over to Houdini. And I'm going to jump in here, just exit the state. And what I've done here is I've grabbed the animation from this network here, which was our little retargeting network, which we saw at the beginning. And I've just object merged that skeleton in. Now, this isn't the most efficient way of doing things, but for prototyping, it's absolutely fine. So I've just grabbed that animation. I'm going to clear any posing that I've done just to keep things clean. And you can see that in the green box that we saw in the slide, I've just grouped some joints on the input skeleton. I've deleted the other ones, and I had to do an extra step here just to make sure that we had a single primitive to work with rather than the 5 that we had on the input. But that's it. We've now got our input for the spline fitting. So here we've got exactly the same network, and here's the spline IK. If I jump here, hit enter to enter the state, and start pulling these around, we can see that we've got that affecting the skeleton. Now, taking a little pause just to clock something here, which is that I said I'm pulling in an animation, so I've got an animated input to this, to which we're attaching this spline rig. And then anything I do to it is layered on top of the input. So this is a very, very powerful concept. We've basically got a rig setting itself up live from an animated skeleton. We're modifying it and then writing that change back. So this is a very, very key idea, and we'll be seeing a lot more from that as we go forward. The next little bit that I wanted to do, of course, was you can see that as I pull these things around, we're throwing the hands about. Now, this might be fine, depending on the input animation. For me, I thought, well, let's have an option to just pin those. So I've isolated the input hand and elbow positions. I've also done it for the feet. I've removed all the parenting information as we saw before. And then we've got an extra little step here, which is to attach some controls just to differentiate them in the viewport from the other points that surround it. So if I come back in here, we can see that we've just got these green points. If I come back up here, and I'll just add a control. On the right-hand side, I'm fetching some geometry from other object nodes. So I've got a simple null control here. I'm just going to hide all of this stuff. And I've got a custom control that I made using a simple circle and a transform. So back into here. I'm going to select the joints that I want to attach the controls to, and for the ends, I'll pick the custom control, which is here. And for the twist controls, I'll just use that simple null. And there we go. That's that. So now as I come back into the rig pose, I can actually hide the joints, and I can now use these bits of geometry to select in the viewport. Okay, so there's our IK working. I've still got that silly pose on the spine, which is why we're seeing some wonkiness. So let's come back and see what we've got as we play backwards and forwards. We've got the input animation with those controls attached. Okay, so we've successfully identified a couple of processes and put them together in a network. I will just touch on this very, very briefly, which is that VOPs, of which we have many new ones in the KineFX tools to perform constraint operations and IK solves, VOPs really start to shine here over writing VEX code in wrangles. Many of you will still prefer to do so. But when code gets more complicated, it becomes much harder to identify what processes we can encapsulate nicely. It becomes a bit more of a mental effort, especially when we might be prototyping and working a bit more fast and loose. And building things in VOPs is really nice because we can see the input wires to our various functions, and we can see where those wires converge onto a single input value. So we can identify more like this which parts of our network we can wrap up into a single verb, if you like, a single action. So that's just a little note here, so do check out the VOPs that we have to use in KineFX that have all been designed to work with these, with transform matrices for rigging purposes. Okay, so reuse and repurpose, I mean, we've already seen that. We've taken our little prototype and we've applied it to the Eric rig. And the next thing is just to keep iterating on these setups. Once we've got a little process, we can continue to stay within it and keep refining the results that little process is giving us. So we've seen a little start of Eric's test rig. We've got our spline IK for the spine. We've got simple IK for the arms and legs. And the next thing was a head lookat derived from the input. So this is very straightforward to do. We can look at the input animation for the head, offset its translation along the direction of the gaze, and use that to drive a lookat after we've run the spline IK. We'll have a look at this in a second. The next little bit is the hand controls. So hands are often something that's a dead giveaway in motion capture retarget. It's becoming much more common for motion capture suits to have support for fingers, but many old motion capture files don't have animation for the fingers. So being able to add a little bit of more natural motion to the hands is something that can really bring a retargeted animation to life. I've already touched on the adding of control geometry. So this is all stuff that we can do as part of the process of iterating on things. So let's take a look back at this test rig. So I've taken all of what we see here, and I've wrapped it up into a subnetwork. If you don't know about doing this, then we can do this just by selecting a bunch of nodes and hitting this box up here. And that will wrap all of that up into a single node. So keep an eye out for your individual behaviors and how you might be able to collect them and keep your networks organized and clean. So very, very powerful stuff. The next step beyond this collapsing is to actually create a digital asset from them. And there's plenty of documentation on this, and we'll see it in all areas of Houdini. So this is definitely not something specific to KineFX. It's been in Houdini for a long time, and it is really essential to a lot of workflows in Houdini. So I've gone and done exactly that. If I crack open this network, it's not as clean. I did this before I had organized things properly. But here we've got our fitting of the spline. We've got the spline IK solve. I've then got that head lookat. So if I have a look in in this network. If I bypass this, this is the add joint VOP is just allowing us to debug where this transform is. And we've set this with a parameter that I've promoted. It just allows us to set the sort of gaze distance, if you like. And this is offset from, whoops, the original animation, so the head on the second input. I've then offset along the negative y-axis by that amount that we saw to the point here. And I'm using that to drive a look at constraint from the current position of the head. So this is where the head ends up after we've pushed the spine around with the spline IK. So we're looking at that, and we're just making sure we're looking at the same position as we were in the original animation, and then writing that back out. So a quick blast over this, and do forgive me for the brevity. I'll be covering this in more detail elsewhere, but this is just a little example. We've then got our setup here for isolating the IK controls. And here I'm actually deleting the joints on a static copy, a time-shifted copy. I'm deleting the joints, and then I'm copying the transforms back. I'm then unparenting everything as I did before. And what we're seeing here with the compute rig pose, the compute rig pose is the core of the rig pose node itself. So if I dive inside here, we can see that we just have a single compute rig pose node. Again, beyond the scope of what we're looking at here, and I will cover this elsewhere, but this gives us a very quick way of promoting parameters to an HDA when we want to be able to pose from a digital asset. So we can see this up here. If I just match the current definition, and I'll change the display flag here. Here I am with the locked asset selected, and the rig pose state has been built to enable it to be used on custom digital assets. So we can see the rig pose or the compute rig pose nodes contained within and display their geometry in the viewport. Okay, so that's that bit. And if I come here and I'll just clear all of this, once again, it's worth emphasizing that we can bring in this animation and have access to this rig. The rig has attached itself, and what we're seeing here is the result of the rig on top of any input animation. Now, what we were actually here to look at, of course, was the hand rig, and the hand rig introduces another interesting little idea that's worth sharing. That because the skeleton is just geometry, and we can use geometry nodes to operate on it, we've got a couple of other possibilities. So here you can see I've got a little hand rig here. I'm going to make sure that we can see the output. And we've got a couple of broad hand posing controls. So we've got a curl control here, and we've got a bit of splay, which of course we can make these negative as well to bring closer together. And same thing on the other side. The way that I've set this up is actually I'm not using rotation parameters at all. What I'm taking is a collection of poses that I've made before, just from the rest position. And I've posed all of these here. So there's the left hand curl. Here's the splay. And the same thing for the right hand over there. This is, again, slightly beyond the scope of what we've got time to cover, but I'm just wrapping these up into a single primitive and then merging them all together to make a library of poses. This little hand rig takes that collection of poses and then feeds these into a blend shape sub. So this is a geometry node. This is used for blend shapes as we would normally think of them. But for some versions now, it's had support for properly interpolating the rotation of normals, quaternions, and transforms. So we get a really nice result out of this if we just feed in these separate poses, and we can use this node to blend between them. I'm then having to do a couple of little extra bits just to conform things, but nothing too onerous. And here we have it. This is our broad control, and I've also promoted the state, so we can also manually adjust each of the finger joints after we've performed these controls, these broad controls rather. So again, I can come and grab these guys and quickly create a pointing motion. Pointing pose, rather. Okay, so that's the little hand rig. So this is cool. So we've now got these two rigs, and of course they're layered on top of one another. You can see that the hand's pointing here, and if I move this around, that pointing pose is still getting applied afterwards. But I've still got to hop backwards and forwards in the network. So this is another example of a little prototype idea. If I just want to be applying hand animation after a retarget, then I only need this one. If on the other hand I want to be doing a bit more, then maybe it would be nice to have the hand available to us in this rig. So I'm quickly going to run through how we might be able to do that. I'm going to open up the type properties for our asset. I just need to change how many inputs the node accepts. And I also need to add the parameters that drive this stuff. So I'm just going to take this whole network. I'm going to hit Control-C, jump back up into our rig, and I'm just going to apply these changes, after the rest of the rig has run. And then the output will be this. We can see the warning here on the blend shape node, and it's just telling us that, firstly, it's telling us we've got bad parameter references. So this is because I haven't added the parameters back here. The other problem that we'll have is that we haven't actually got our little library of poses. So the first thing is to just butcher the controls from the hand rig. I'm just going to drag those over here. And Houdini will actually create references back to those parameters, so I just need to make sure I clear all of those. And I'll hit apply, and we should see that we get another warning here telling us that we haven't got enough inputs, basically. So I'm going to find my second input that I've just created. So I'm zoomed out a long way. Bring this, plug that in. We're getting a little warning. Not enough sources specified. Well, no, you're quite right. I haven't connected our library of poses. Okay, and we have one more step to do, which is just to rename this parameter. So I'm going to say hand transformations, and I'm going to promote these parameters. Just going to close this here. We'll come back up, clear any edits, and we'll see that we've got a new bunch of parameters here. Now, of course, we can organize these better and make things look nicer afterwards. But there we go. There's our hand transformations parameter. I'm going to save the node type, match the current definition. And you can see in our state, we now have access to all of this, including our broad controls. And everything's hooked up. So that's an example of keeping on iterating, exploring these atomic processes, and then still being able to merge them all together, extend assets that you've already created. I'm now going to just delete out that asset, and there we go. Once more, having saved this, I can now drop this into another network. Look at my HIVE test rig here. And I'll plug that into the animation. Oh, I haven't got my hand poses. This might be a design flaw. It's certainly something that we can rectify later on. I'm just going to copy and paste this in for now. Okay. And this is now attaching itself to the input. You can see that I've already got the hand curled up here. Bring that back to normal. And Houdini being Houdini, if I change the input animation, let's see what we've got. I did have another one available to us. I can't remember which one I was using that was a good example of this. Let's just try the first one, and we'll see what we get. Okay, so we've changed the input animation. Okay, there we go. And this rig is, once again, still attached. And this does make a nice example, because as the animation goes forward, we can see that there's a contact point just down here, which is completely wrong for this character. So we can use our rig to adjust this, and I probably want to start where the hands aren't colliding, add a keyframe, scrub onwards, and just start positioning the hand where it makes a more sort of natural pose for the character that we're dealing with at this point in time. Obviously there isn't time for me to do a proper polished job of this, but we can see the principle is there of being able to use this little custom rig to refine our retarget and get the results just how we want them. Okay, so I believe that covers everything that we have here. As I've already alluded to, this is just the beginning. We're definitely not dusting our overalls off and calling it a day for the world of character work. We're very aware that there's long ways to go in providing the kind of interaction that you would be looking for doing full character animations in Houdini. So we will be earnestly improving the tool set as we go forward. And in the meantime, we really look forward to seeing what you guys do with it, and look forward to hearing from you. So thanks very much for watching, and I hope you enjoy the tools. Bye for now.
Hey, next up we've got Mikael Pettersen. Good to see you, Mikael.
Hey, good to see you.
So give us a little background on yourself.
So I'm Mikael. I'm head of simulation for MPC Episodic. I started out as a journalist in advertisement, and the tempo was pretty fast. And then I went to film, where the tempo was less fast. And now I finally found the golden middle ground in Episodic, where you have enough time to do cool stuff, but it's fast enough to not get bored.
Mm-hmm. So what's today's presentation going to be about?
It's going to be about KineFX and all the cool thing that brings to crowd.
Right on. Well, let's get started.
Cool. Let's go.
KineFX is making crowds even better in Houdini 18.5. So instead of having to go into chops to modify agent clips, we can now use motion clips. This makes it so much more convenient to fix stuff with clips like intersections, mirroring, removing weird frames, blend clips, and so on. The cool thing with motion clips is that you can convert between them, poses, and clips easily, and use them for different things. I'm going to show you a few of these in just a minute, and you'll see that it will open completely new workflows. It's a massive level up for crowds, and crowds in Houdini were pretty ace already, so woohoo! Today I'm going to start with some motion clip basics, Then I'll show you an example of clip blending, and then I'm going to demonstrate how to promote agents from a crowd, tweak the animation, and then convert them back to a crowd again. Let's get started. Okay, let's start by dropping down a mocap biped 3. And I'm going to go to zombie, and I'm going to uncheck this in place. And then I am going to create an agent by dropping down a geometry and an agent sub. And then I'm going to point to the zombie. So here we go. Cool. Okay, let's see what we can do with this. So first, let's drop down an agent animation unpack. And if we look at this, we can see that we have a few different options. So the first option is pose. So in that, we have this little stick figure. And then we can turn that into motion clip. And then suddenly we can see each frame at the same time in the viewport. And then we have packed motion clips. And if I switch over to that, it doesn't seem to do much of a difference. So what's going on here? If we go back to motion clip, and then I'm going to go to the spreadsheet. Here we have 240 packed geometries. You can see that middle click here, packed geos, 241 actually, yeah, because it starts on 0. Each packed geometry is a frame. So if we go to the primitive tab, we can see we have a time sample on each packed geometry as well. But if I would switch to packed motion clips, now we just have one packed geometry. You want this if you want to add multiple motion clips to an agent at the same time. Otherwise, you have to add them one by one. But if I would unpack this, and then I'm going to close this down. Now we're back, so we have all these time samples again. And let us just unpack it one more step. And here we can see what's going on under the hood. So now we have all these polylines, and on all the points, we have a name attribute that is referring to the joint. And then we have two matrices. We have a local transform and a transform, and that is a structure of a motion clip. Okay, so I'm going to close this down, and I'm going to delete this unpack. So let us just feed this back to an agent. So I'm going to use an agent clip node. And I'm going to connect these two. And in the input menu, you can now see that we have motion clip as an option. So we can select that. And you can see also we have this checkbox here, treat packed primitives as inputs. And that is if you are using packed motion clips. And that reminds me, I need to go up to output here and set it to motion clip. I just want to add this one clip. So I'm going to call this clip updated. And now in this set current clip, we can see we have updated and we have walk. Obviously, these will be the same now because we are not doing anything. But let's do something so we can see the difference. So I'm going to set this to updated. And then I'm going to drop down a motion clip retime. And this is exactly what it sounds like. You can retime the clip. So for example, I can set the speed to 0.5. And now you can see he's moving very slowly. I can set the start frame and the end frame. And it's floats, so you can set it on subframes. So simple, but kind of useful. So let's try something else. Another thing we can do is that you can delete part of the clip. So I'm going to drop down a motion clip post delete. So I'm going to connect this. And just to see what's going on, I'm going to take a chunk out of it. So I'm going to do, let's have 20 to 40, and then uncheck this. So let's say we have this little gap here, and I can connect this again. And if we look at this and see how the agent moves, you can see he slides over there in the gap. So he interpolates between these two frames. And the timing is, of course, the same as we have the time sample on each packed geometry. So that's pretty cool. Let's do something more exciting. Turn this to pose. And I'm going to show you how to mirror a clip now. You could do this before, but you have to go in and make some logic in chops, and it was not very straightforward. But this is way easier. So you can see, like, immediately by dropping this down, I have a mirrored version of him. So here's the old version, and then we have the mirror version here. And now we have it as a pose, and that won't work with the agent clip node. So we need to convert this to motion clip, but that is very straightforward. We just need to drop down a motion clip node. So you can see it like that. So now it's back being a motion clip again. And by the way, you can also change other things here. You can see you can change the frame range, you can change the sample rate, and you can also pack the inputs. You can see you have multiple inputs, so you can plug in more than one pose in here. But let's connect this back and see what we got. And now we got this weird skinning issue. And this is just because the rig mirror pose are not really sure which of the joints is supposed to mirror. So now it's mirroring the shoulders as well, and we don't want that. If you go into the rig mirror pose, you can go down to this position threshold and drag that up a little bit, and then you can see it's gonna work itself out. So now we have it mirrored. Cool. And now you can see the previous one and the new one. Okay, so let's do something else. I'm gonna take this away. I'm gonna save this guy up here. I'm going to drop down a new agent animation unpack. I'm gonna set that here. So I'm gonna set this to motion clip. So another thing that you need to do sometimes is that so maybe you have like a weird frame that you want to do something with. Then you can use this motion clip pose insert. So what that does is that you put in your motion clip in here, and then the pose in here, and then you tell it what frame you want to overwrite. So in this case, because we are feeding the animation back, it will be the same frame, so it won't do anything. But let us drop down a time shift. And in the time shift, let's set that to 40. Up. So now we just have this frame, and then let's insert that on frame 20. So if we look what that gives us, you can see if we go to frame 20, you do a little jump because that frame has been overwritten now. You can use a rig pose to just correct him further. And now you can see we have him with this corrected pose. So maybe you want to do even more, you want to overwrite a bunch of frames. Then it might be easier just to do it this way. I'm going to drop down a motion clip. And I'm going to remove this time shift here. And then connect these guys. And then I'm going to clear this out. So now I'm basically just feeding in a pose that gets converted. But this means that I can also keyframe it. So for example, say I want him to, maybe I want him to start looking this way. And then I keyframe that. And then on this frame, here he's starting with his head twist. So you can see him turning his head. You can of course just tweak it how you want it. Obviously you could do a similar thing with agent edits before. This is just a bit nicer. But it's obviously still just FK here. But a really cool and powerful thing you can do now is that you can just create IK chains on the fly. So let's just have a look how to do that. So I'm going to remove that one, and then so now we have him as a pose. So the first thing we need is to create controllers. Say in this case I want to make this arm to an IK change. So then I will need an effector. I want something to control the elbow and the root. An easy way to create controllers is to use delete joint. So in this way I can go in here, I can just select these three, and then delete non-selected. So now I have these two polylines with 3 points. Then I can drop down an IK chains, connect these two in here, and you can see I can have multiple IK chains, but in this case we're just going to create one. I want this to be the root, and I want this to be the elbow, and then I want this to be the effector. Then here you have match by name. If I check that, it will just match up the effectors with the name attribute. And because we are using the same skeleton, these guys will have the same name. This is very convenient because first of all, you get the controllers placed correctly, and then you also automatically have them connected by name. So by doing this now, I can drop down a rig pose again. I don't have to use a rig pose, by the way. So this is just points. So you can just create your own logic in Vex or do something else procedurally, and it will just work. But this is just a convenient way of moving stuff in the viewport. So I'm going to take that. So I'm going to move the elbow back a little bit. And then maybe I'm gonna drag the hand over here, something like that. And now if we look at this, we have this blend slider here. So if I drag that, now you see he'll try to solve the IK chain. Now it's a bit overstretched, but let's go back here. So it's working fine, as you can see. And then connect that to the motion clip again. And if we look, now we have our result. Whoop! We have his flimsy IK arm I just created. And if I drag that back, we get the other one. We get the old one. One last thing I'm going to show before we go to the first example is I'm going to show you a little workflow tip. For a lot of clips, you're going to have them being in place. So if I would create this in place, let's have this set as a motion clip. So I will set this agent to in place. So I will say, okay, the hips are the locomotion node, and then convert in place. You can see, first of all, you get this extra node that is locomotion, so you can see the motion through the clip. You also have all the frames overlapping, so it can be a bit hard to see what's going on. The good news is that these point positions that you have, they're just for visualization purposes. So you can actually move them. So what I usually do is I drop down a wrangle, and then I do something like I'm going to move it in Z, and then maybe I take the PT num, and then multiply that with some spacing, something like that. And then let's create that parameter, and then I can just drag this out, and now I can see a little bit better what's going on. And this won't affect the clip at all. So if we go back and have a look on this updated clip, you can see he just looks as usual. So yeah, cool. Let's go to the first example. Okay, let's use something else than Mockup Viper 3. So I'm going to drop down a geometry. And here I'm going to drop down an agent sub again. And I'm not going to use character rig. I'm going to import an FBX. And I'm also going to uncheck this convert units because it's not done in Maya. Scale is correct. I don't need to scale it down. So there we go. I also downloaded some free mocap online. So I'm going to have an FBX animation import. And then I have this run, for example. Running there. Let's call that run. And then I'm going to duplicate this, and I'm going to have a kick as well. So there's a flying kick. Okay. So the first thing I want to do, I need to retarget this, obviously, because it's not the same rig. Before I do that, I just want to roughly match up the scale of the rigs. I can use a rig match pose for that. Also, I need to convert this to an agent animation unpack. So I need to have a pose. So here we have a pose of the T-pose. And so I can connect that in here. And then you could just connect it like this and then start tweaking this guy, try to match them up. So they have roughly the same pose. But that seems to be a lot of work, so I don't want to do that. So I'm going to clear that. This actually comes with a T-pose as well. So you can see I have the FBX clip name. I have a take one, there's a T-pose. And then I have the other one that is just animation. So let's just copy this. And call this T-pose. And then let's set that to take one here. So there we go. And in this rig match pose, one of the things you can do is you can have a reference frame, which is a frame that you want to use for the matchup. So I'm going to use a switch here. It's not like a super elegant solution, but it works. So I'm going to do it like this. And if I middle click that, I can see this is 22 frames. So then I can say, okay, so if the frame is more than 22, then I want it to switch, which means that he runs and then he goes back to T-pose. So then I can just go to this rig match pose and set the reference frame to T pose. Or I can set the reference frame to 22. So like so. So now by doing that, oh, not 22 actually, because it's over 22, so 23. Now we can see that they have the same pose. And I don't want to scale this target skeleton, I want to scale the source skeleton. So here we go. And then I'm going to drop down a map point. With this we can define what part is driving what. So if I go here and I can move one of them away a little bit, I can just start matching them like so. But you don't have to watch me doing that, because you can also export the mappings, so we can just import what I've done before. So I'm going to change this point number to attribute values, import mappings, and then here you go. So here it's mapped up and ready. Cool, so now everything is ready for the retarget. Now we just need a full body IK. I'm going to drag that here, and what do you know? Boo! We have a retarget version. So I'm going to convert that to motion clip, like so, and here we see that. And then let's see if it works. I'm just going to have an agent. I'm going to have an agent clip, and then I'm going to attach this. So again, motion clip. I'm going to call this updated or new clip. New clip. Let's see if it works. New clip. Oh, I connected this to the second port here. It should be on the first port. So by doing that, now we have her running. Very cool. Okay, so that's the first step. And what I want to do, I want to blend this FBX with this FBX. So let's do that. So just to make it easy for myself, I'm just going to copy this because I know this is working. So I'm just going to do it like this, and then I'm going to, instead of a run, I'm going to connect that to the kick. I'm going to middle click the kick and see it's 46 frames. So then here it's going to be 46. And the rig match pose is going to be 47. So here we go. So here we can see the kick. Cool, okay. So now we have that ready. Now I want to blend these two together. I want to use a motion clip sequence and connect them like this and see what we get. So let's go. And here we see she's running, but then she gets blended back to the beginning and do the kick. And that is obviously not what we want. We want her to start doing the kick over here. And then in this motion clip sequence, you can set the locomotion joints, you can set the hips, for example, and then you can set translation. I want to use the locomotion joint. And now you can see this is moved forward. Cool. Okay, so let's see how that looks. So it's kind of working, but it's not great. So you can see, like this foot should be planted, but instead you get this blend when it gets slides back, and then she does the kick. So what we want to do in this case, actually, we want to do the blend around the foot. And you can specify that. So you can go to this match translation, and then you can choose custom joint, and then you can just select the right foot here. Right foot. And by doing that, now you can see she's taking off from the foot. And it's a little bit wobbly here, so let's put some blend frames there. So now we have a little bit of a blend, or maybe even more. So there we go. It feels like she's going slower when she does a kick. So maybe we can do like a retime here. And set that to, oops. And set that to, I don't know, 0.9 maybe. Whatever you feel is right. Whew. It could even be slower. That looks better. Yeah, this is cool. I have this clip, but I obviously want to use locomotion in my crowd later. And now I just have this. Now I have this agent moving within the clip. So how can I change that? There's a node for that actually. So you can, if you convert this back, if you do motion clip and do evaluate, you're gonna by doing that, it converts this to pose again. And then you can drop down this extract locomotion. You specify the hips as the locomotion node, and you see now you get this locomotion node here, and the animation is in place. So now we can convert that back to a motion clip. And by doing that, now we have her in place, and we can also use this apply locomotion, and then you will see her running. Woo! So let's try something more advanced. So we have this crowd here, and what I want to do is I want to take two of these agents, these two here. I want to promote them to animation. I want to do some stuff to it. In this case, I want them to hold hand, and then I want to convert them back into crowd. So the first thing we need to do is to convert them to poses. So I can use an agent character unpack for that. If we go to the yellow third port here, we can see now the whole crowd has been converted to poses. But we just need these two, so let's go and select them. And now we have just these two. Sweet. So step number 2 is that I want to have a point that I can connect the two hands to. So what I want to do now is I want to create a point roughly in the middle. That's going to be my base. And I'm going to do that by taking all these points and I'm just going to average them out, and then it would be like roughly here. I'm going to promote the point position to a detail attribute. And then I'm just going to copy it. And then I'm going to promote it back. So by doing that, now we can see all the points have the same position, roughly where we want them. And you can see we still have all the points, and we don't want that. So let's have a blast. And this blast, let's do set points, 0, delete, non-selected. So now we have 1 point that we're going to attach the hands to. Step number 3 is now it's time to create some controllers for the arms. We're going to use the delete joints again. And then I'm going to select the ones I want. So I want to have that one, that one, and that one, and that one, and that one, and that one. And then delete non-selected. So here we go. I also want to move back the elbow controllers a little bit. So I'm sure that they're always behind the agents. I'm going to do a transform, and then I'm going to just drag them back here. So that's good. Another thing I want to do is right now I have all the transforms still on them. If we look at the points here, we see we have this 3x3 matrix. I don't want that because I don't want it to influence the IK solve. So I'm going to have an attribute delete. And then I'm going to set this to transform. Like so. So now we have the controllers and we have the point we're going to attach them to. So let's attach them to that point. I'm going to have an attribute copy. And then I'm going to copy the point position. Now all the points get that, but I obviously just want the bottom one. So I want these two. And there we go. Okay. So now when we have that ready, let's create the IK chains. So I'm going to have IK chains. And then I'm going to connect these. And you see I get an error. And I get an error just because if I select this, for example, you can see that is called right arm. And this guy also have a right arm. And that is a problem. So now this node gets confused and doesn't know what to do. In this case, because it's just 2 agents, we could split them in 2 and then set up IK chains per agent. But sometimes say that you have lots of agents and it would be very impractical to split them up. In that case, we can add a prefix. So I'm going to go up here and I'm going to drop down a wrangle. And I'm going to set that to primitive. And then I'm going to say, I'm going to have a prefix. And that is going to be equal to the agent name. So if we look at this, you can see we have a name that is unique for each agent. And now we have a prefix that has the same name. Okay. And I'm going to promote that to points. So here I'm going to have prefix. And from primitive to points. And I can tell this agent character unpack, please transfer that attribute. So I'm going to say prefix. So now I can construct a new name from this. So I'm going to have wrangle. First of all, I'm going to save the original name because we need that later. I'm going to say old name equals to name. Okay, that's good. And now let's make a new name. So I have name equals to prefix. And then let's have an underscore. You don't really need it, but it's easier to read. And then name. And if we would look at this, you can now see that we have the old name with the original name. And we have this new name, which is the prefix plus the old name. And now we are ready to solve. This still gives an error, but if we just cut it out and Control Z, then it works. And then let's select her, and that one, and that one. And then match by name. And then let's create another one. That one, that one, and that one. And match by name. If we now drag this blend up, you can see it's trying to solve. It's not great though, because it can't really reach that point. So we could just add a rig pose. And then we can start manipulating these guys. Oh, another thing I'm going to do, by the way. I'm also going to go to the IK chains and I'm going to say orient tip. And that way, when we rotate the hands, that will be picked up by the solver. So I'm going to have orient tip and orient tip. And now you can see it can get like freaked out from it, but can easily adjust that. So this is a nice feature. So if I go to here and we have 2 points in the same place, so then I suddenly get them with the name here so I can see which one I select. So let's select the lady and I'm going to rotate or something like this maybe. And then let's do the dude. Still not great, but let's first convert it to crowd agents and then we can see it a little bit better and then we can tweak it further. So I have these two solved, and let's uncheck this template. So we have these guys, and now we want to convert it to crowd. So we can use an agent post from rig. If we just do that like this, nothing happens. And nothing happens because this is looking for the joint names, and we have added a prefix to it, so it doesn't match up anymore. So what you can do then is that you can drop down a wrangle, and we can just retrieve the old name again. So we say name is equal to old name. But now everyone gets over here. So everyone is using this rig. And it's the same problem as before because it doesn't know which one it's supposed to use. So it's just take one of the poses and it just attach all the agents to that. So you need to have some logic to separate them. And one way you can do that is that you can use a for each loop. So I'm going to drag that up here. I'm going to just take them away for now. And by doing that, now it's just going to loop through each agent and do something. Cool. So what I want to do is I want to see, I will basically check. For each agent, I'm going to check this one. Is the prefix the same as the agent name? In that case, then I know it's correct. Otherwise, I just want to remove it. So if this is... So, for example, if we are on Sarah 3, we want to remove all the Andre 3 and so on. So the name here is going to be a primitive, so let's just promote the prefix to a primitive again. So I'm going to have a promote, an attribute promote, we do point to primitive prefix. Okay, that is the first step. Then I'm going to have a wrangle. I'm going to let this run over the primitives. And then I'm going to say, hey, let's check out the name. So we do if, and if the prefix is not equal to, and we do the primitive from the second port, and then name. And here, because it's looping through each agent, so every time the primitive number is going to be 0, because there is just one agent. And then, so we can just set this to 0. And then let's see, if they are not matching, then I want to remove it. So then I do remove prim at primnum, and I want to remove the point as well. Let's see if I loop through this, and there you can see. So here, now I get that one, and here for that one, you get that one. That is exactly what we want. So now from that, we can just add this guy back in, and like so, and now suddenly we have this out. Cool. And then from here, because they're still not great here, so you can still use the rig pose and just go, move him up maybe a little bit. For example, his hand or her hand, and his hand. Something like that maybe. And there you go. Very useful stuff. That's it for me. I hope that you learned something, and I look forward to see what everyone will create in the future. I am out.
Hey, Simon.
Hey, Chris.
Welcome to the Hive. So give us a little background on yourself.
So yeah, I'm Simon Verstraete. I'm a tech artist, and I focus on creating procedural content with Houdini. And I've been making tutorials, demos, also for SideFX, of course. I have also my own YouTube channel.
Awesome. And you're the author of those really great assets that we included as part of the Game Jam this year.
Yeah, definitely. I create a few tools that everyone can try out to like play around with, generate some simple things, and get their first experience with the Houdini engine.
Excellent. So what's this presentation going to be about?
So we recently announced with the last presentation the new plugin for Unreal Engine. So I will talk about new features. I will show all of the features and talk a bit about them, show more how to use them and how to enable them.
Right on. Let's dive in.
Hello again. And here we are at the presentation. So as I mentioned with Chris, I'm going to talk about the new Houdini engine for Unreal 4. So during the launch presentation of Houdini 18.5, there was an announcement for a new plugin for Unreal 4. So this talk will go over some of the new features and also show you how you can use them as well. So during the Houdini 18.5 keynote, there was this desert scene that was used to show some demos. So we'll use this desert scene as well as sort of a guidance to show off new features. And I will also show you here a bit more about this desert scene. So this desert scene was a procedurally generated scene with Houdini and working, of course, in Unreal Engine. I've also used some Quixel assets and assets of my own to make this possible. So again, what you see here is generated procedurally. So we generated landscapes, placed down procedurally foliage, rocks, and other models. Here is already a quick look inside of Houdini. So I generate this landscape, and on the landscape you can see a couple of these points. So each of these points contain an instance, which can then be rocks, foliage, and other things. You can also see here that I used a PGG setup, which I will talk about more later in this presentation. Now, before I jump in all these new features of the new plugin, let me just talk about Houdini Engine in general. So what is Houdini Engine? So this is the plugin that allows us to open Houdini tools inside of game engines. So for example, we have support for Unreal and Unity. This will work in editor time, so this will help you build your worlds faster. So you can have a house generator, rock generator, or other building tools that can help you make your environments or other things way faster with a procedural workflow. The Houdini engine itself is included in the installer. So whenever you install Houdini, always keep an eye out on enabling the Houdini engine to be installed as well. Now let's look at the general workflow of using Houdini engine. So we will have a Houdini user who can make these awesome procedural tools. So for example, a house generator, certain world generator, or other building tools to help up speeding certain processes of your workflow. Now these tools or digital assets can then be shared with the studio, so everyone can look at these tools and use them. So with the Houdini engine, everyone is able to then open it in, for example, Unreal, Unity, Maya, 3ds Max, and other software as well. So it doesn't require everyone to be a Houdini user. As long as they have the Houdini engine, they will be able to open these procedural tools in other software and use them in a user-friendly menu. So let's take a look here at Unreal. So here I have a building generator, and on the right side we have that menu. So as you can see in that menu, we will have a few parameters and buttons to then, for example, cook the asset or change, for example, the floor height and so on. So this menu is user-friendly and only has the parameters you can build for it. Let's look here at the video of that. So here I have a sci-fi portal that I used in my desert scene. And I have here a few parameters where I can change, for example, the radius, the band size, other lengths, rotations, and so on. So this allows me to quickly get variation on this model. So if you want, for example, 20 different versions of this model, I can easily, under an hour, bring up 20 versions, and then we can always decide what are the best versions and go from there. Also, this model uses some nice trim sheet tools. So with Houdini Labs, we will have soon some trim sheet features to procedurally generate that. So now we have some idea of what the plugin can do. So it allows us to open these procedural tools inside other software. And we are of course specifically talking about the Unreal Engine. So now let's talk about the version 2. So version 1 is still available, but we're also now releasing version 2. So this is still in a beta form, and you can already try this out, of course. So now let's first talk about new features that are in this tool. So I'm going to go over each of these, and I will show you and explain a bit more about them. So let's start out with the new user interface. So the plugin has been rewritten from scratch, and also the interface has been rebuilt. So here at the top in the left image here, we can see that we have our basic Houdini engine parameters, like we can rebuild an asset, bake out assets, and so on. Beneath there, we then have our normal Houdini parameters that we customly made in Houdini. So in this case, it's from the sci-fi portal. So we have, for example, the band size, some of the pieces, and so on. Then here on the right image of the slide, you can see a new menu at the top of Unreal. So we have this button there called Houdini Engine. And when you click on it, we will now have this menu. So this can be used to connect to Houdini or other settings as well. Now overall, the menu has gotten a cleanup. So there have been general improvements on using menus, using folder structures, and so on. There are also more support for certain parameters like log integers, multiple string, and so on. So we can overall say that the menu is being cleaned up and is now a better way of working with it. Now next up I want to talk about one of the bigger features, which is called PGG. So version 1 didn't really have a PGG support, but version 2 will come with a PGG support. So it will also have its own menu. So with the new menu, we also now have a specific menu for PGG. This menu will automatically appear when your digital asset is using a PGG network or top network. So when this menu pops up, we can see at the bottom of this menu, we can have waiting, cooking, cooked, and failed status. So we can visually keep track of what your PGG network is doing. We also have support for async import if you're looking for that. Now next up I want to show you a demo of this PGG in action. So I'm going to use my desert scene again here. So in a moment you will see that my PGG network is going to cook and parts of my terrain will be loaded. So here these 3 tiles have been loaded in and there will be popping up more and more one at a time. So in this case my terrain will be a 4x4 tiles. So I will have 16 different tiles as output. So this PGG network outputs a landscape and also these props. So everything you see here is procedurally being calculated and placed. Then also here a quick look inside of that PGG network. So I will start out with generating a basic terrain. Then I decide how many tiles I want. I'm going to split and scatter on these tiles then as well. Important here is that we can use a output which is called HIVE. Whenever we name an out node HIVE, this will be able to see in Unreal. So here as you could see, whenever we use that specific naming, we will be able to see that inside of Unreal Engine, and we have a drop-down menu to cook specific nodes. So this allows us to output specific versions, like I only want to see, for example, the terrain, so then we'll select the HIVE terrain. Or I can output multiple parts of my PGG network. Now, next feature I want to talk about is world composition, and this also really works well with PGG. But first, let's talk a bit about world composition. So what is this? So this is a feature from Unreal Engine, and this allows us basically to create larger worlds. So they have this special menu and setups to manage your worlds also better as well. So you can nicely order your map tiles next to each other and make the world you want to. By default, there will be also some automatic streaming distances. So based on the player position, it will load and unload parts of your world. As you could see here on the image, on the right top there, parts that are being grayed out are unloaded and the colored parts are currently loaded. So let's take a look at that working in the desert scene. So here I'm walking around in a desert scene. This has been speed up, of course. And in the right corner, you can see that the gray parts are unloaded and the colored parts are getting loaded. So this is basically what you get out of the box. So these are basic values, and you can always change them, of course, but out of the box, when pressing play after generating, this is what you get. The levels are streaming. So now let's talk a bit about the workflow of this. So as I mentioned, this works nicely with BGG. So the first step will be generating a world. So in this case, I used Houdini with BGG to generate this desert scene. So this will be the world that I generate. And then, of course, I want to then bake out this result. So I have my Houdini engine opening all my generated things from Houdini in Unreal. And I want to bake out now the result. And in there, we have now a bake button in the BGG menu. So whenever we click on the bake button, instead of outputting one big solid landscape, it will actually output different maps. So as I mentioned before, I have a 4x4 tiles. So I have 16 different landscapes. And this also will be the output. So I have 16 different maps. So you can see that they go from terrain 0 to terrain 15. So each of these levels will contain the landscape and the props for that specific tile. And this is all done automatically pressing the bake button. Now all these maps are then used in the Unreal level system. So we can load them here in the level menu, and then we can also here assign streaming values and so on. And we also have this new menu from world composition where we have this top-down view of the desert scene. So in this case I can, for example, click on parts of my terrain, and as you can see I clicked on my mouse on terrain number 5, and I can see some of the values like the position, the streaming distance and so on. This menu even allows us to drag this whole tile to another place if I want it. So again, this menu is really useful to manage your world after procedurally generating it. Now, to set this up, this is driven by attributes. We will also have a lab node that will help you setting this up. So instead of creating all these attributes by yourself, we will have a tool for that in labs that set up some of the basic attributes. So the main attribute we want to use here is actually the level path. So we want to say where we would like to save out these landscapes and props. So when you press bake button, they are nicely structured in your project. Furthermore, on the lab tools, we also have a visualize option. So here I have a 2x2 terrain, and every color means that there will be a different level as a result. Next up, I want to talk about session sync. This has also been released already for Unity a few months ago, but we of course also bringing this to Unreal with the new plugin. So what is session sync? So you can see this as a connection between the two softwares. So we can send information or data from Houdini to Unreal, but we also can do the other way around. We can have information from Unreal sent to Houdini. So this will bring the software closer together and will open some new ways of working. So here is a quick demo of this. So I'm just gonna play around here with the parameters. And here in Unreal I'm changing the number of pieces or the radius, and you can see that both softwares will output the same result. I can also just go here to Houdini and change the parameters there as well. So it doesn't matter in what menu you will change the parameters, they will both update as well. Now this opens some new possibilities. So since the softwares are connected, we have this extra layer of interaction. There is also some ways that we can use Python states with this. Also PGG is very useful here as well. And the viewport sync is also something that I want to talk about. So let's look at some demos. So here, what I will do is I will make a basic blockout in Houdini, and the blockout will then be sent to the lab's building generator, and from there we will then send that to Unreal Engine to make a final building. So here I have just two boxes and I'm going to subtract them from each other. So I'm just cutting off that corner. I can also here add an extra cube, and this will then have some nice height variation for my building. And now we have my building in Unreal. So it's a really fast way of getting some basic buildings in your game. Now we can take this even a step further and add some more procedural approaches to this. So what if we want to generate a city or layout? So I made a small tool that can generate a very basic layout. So here, whenever I press the random layout button, it will output these cubes. So again, these cubes will go into the lab's building generator and then go to Unreal to give us here this result. And this will give us this nice building. Now with that, we can also use Python states. So Python states are a way of writing a custom interaction inside of Houdini. So we basically can say whenever I click with my mouse, I for example place a cube here on my blockout. So I can generate the blockout here with the randomize layout button, and then I can just click on my blockout to add or remove cubes. So let's look at the demo here for that as well. So as you can see, whenever I click, I place down these cubes, and these changes of course getting automatically transferred to Unreal. So it's combining some procedural approaches like generating a layout and some more manual tweaks by sort of guiding and clicking with your mouse to control more of the layout. Now, as I also just mentioned, there is also PGG with this as well. So whenever we generate something with PGG, we can always keep track in the background where items are cooking. So the new PGG menu inside of Unreal is great, but it doesn't show in detail on what specific node or what specific part it is cooking at the moment. So that's why it's always nice to have a session sync open, so we can visually see on what specific part it is calculating the network. This also allows us, for example, for debugging. When there is an issue, like we have failed items or we have weird placement of certain props or landscape, we can then always go back here in Houdini with the session sync enabled, and we can double check here or working items and see where things went wrong. Now, the other thing that I wanted to mention here is that we also have a viewport sync. So here I'm moving around in Unreal Engine, and you can see that the exact same angle has been transferred to Houdini. So if you're looking for that, then know that this is possible as well. Now overall, I would say that session sync is really powerful. This will open definitely some new ways of working, and personally I really like it for debugging. When you are working on a tool, it probably will happen that some issues will happen and that you need to debug. So now with session sync, I can have an issue in Unreal and I can immediately see in Houdini at what part my tool did not fully work. So it's a great way for debugging. And overall, this opens some new possibilities. Like we can, for example, generate a blockout shape, use that in a house generator and send that to Unreal. This also works on possibilities with Python states, as I also showed you here. Now, I'm going to talk here a bit about how you can use this as well. So we're going to go here to the new menu at the top of Unreal, and there is a button here for Open Houdini Session Sync. So once you click on that, it will also launch Houdini, and it will automatically connect to Unreal. Once Houdini is opened, you will see a node called Global Nodes. When this node is here, that means you are connected and ready to go to send information to the softwares. If this node is not here, I can recommend you going back to that menu and pressing Restart to see if that will work and connect the session again. Now, next up, another feature is the BSP brushes support. So what are BSP brushes? So these are basic shapes from Unreal that you can edit in Game Engine. So as you can see here in the animation, I can drag around primitives or edges or points. So we have a basic modeling feature with these BSP brushes. So often these are used to block out levels and scenes because they are quite flexible, and as you can see there, you can always edit them at any time. So now we have the possibility to use this as input. So we can make a blockout of a house and use this as input for the house generator that I previously used. So the general way of working with this is that we can make a simple blockout of a level or a certain cityscape and then have Houdini procedurally generating the first pass of the model placements. So this will definitely be really useful if you're already using a lot of BSP brushes, so your artists don't have to place every single model manually, but have a more procedural approach with this. And then here is also a demo of this. So I'm going to move down to BSP, and you will see that my house generator will nicely adjust to it. I can also here extrude different faces, and like here I will extrude the top, and it will immediately adjust to it. I can also here extrude the front side here, and my house generator will get the same result. Now the subtract feature also worked here as well, so we can subtract different BSP brushes from one another, and this works here as well for my house generator. So I'm gonna cut off that corner, and I will get the change here as well. Then next up is importing BGO files. So what are BGO files in the first case? So these are the default file type of Houdini. So whenever you are caching out geometry or using PGG, the basic type of file will be a BGO type. Now we have the possibility to import this file type inside of Unreal Engine. So if you use this a lot and you want to import your BGO files, this is possible. This will also mainly support meshes and instances. So let's look at an example of that. So I've built a very simple setup with a box and 4 instances, and I will import this inside of Unreal. So here I will press the import button, select my file. This will then get imported, and as you can see, I also have this blueprint, and the blueprint is containing my instances. So this has an instance actor, which is containing my 4 boxes that I instanced. Also here we have then the static mesh, which is then the mesh that I created in Houdini. So here's that file again. So just the basic cube and 4 instances, and that's it. So that works nicely with the new integration of BGO files. Next up is I want to talk about blueprint support. So now we have the possibility to open our tools or HTAs in a blueprint. So we have this new component, as you can see here on the image. We have a Houdini asset component. So this will mainly create instances and new geometry, so we can procedurally generate geometry in a blueprint. And I also want to say that this is still a early on experiment, so this is an early look at this integration. So know that this is still very basic in use. So here is an example of that. So I can add my Houdini asset component. And in there we then have the ability to then open an asset. So I'm going to use my portal again, so the sci-fi portal. And a few seconds later, I will have that portal generated here in a Side A blueprint. So here we have the exact same menu as well as we did in the normal viewport of Houdini. So we can then here again play around with these parameters and then change and generate more versions. Now another thing, what we can do with it is we can then scatter around these blueprints in a scene, and we can then still keep the link to that digital asset. So whenever I change here the generator in my blueprint, of course the other blueprints will update as well. So this can be a way of keeping this non-destructive. So if you still think it's not good enough and you want to change this later on, you can just, for example, keep it in a blueprint and then generate it always here in the blueprint. So again, this is still an early look at integrating digital assets with blueprints. So know that these are just very basic features, but you can already try this out if you're interested in it. So now I've mainly talked about some of the new features we have added. But also I want to talk about some of the features that got an update or got changed. So let's look into that. So here already is a list of a few things I want to talk about. So again, I will go over each of them, show a bit more about them, and show how you could use them as well. So we'll talk about static mesh creation, instancing, new properties, foliage, input menu, and curves. So let's start with static mesh creation. So static mesh creation. So basically, whenever you generate procedural geometry inside of Unreal, this will be faster. So I'm not talking about making instances, I'm talking about really generating new geometry inside of Unreal. So overall, this will be way faster. So whenever I drag and drop my tool inside of Unreal, it will calculate faster. And also when I change a parameter, like the radius of the sci-fi portal, it will be faster than version 1. We also have something which is called a proxy mesh, which I will show more in a few seconds. So now let's compare them. So I can say that they are faster, but you probably want to see how faster they are. So we have version 1, which is the version 1 that has been available, and version 2 is now the new version from 18.5. So in a moment I will show you a video, and in the video I will change the radius of this sci-fi portal. So here I'm going to change the radius, and here it took around 3 seconds. So this is also in real time. So here, putting them next to each other again. So version 1 took around 9 seconds, and version 2 took almost 3 seconds. So this is already a huge improvement on the version 1. Also, so for more information, this model was about 55,000 primitives. So this calculated pretty fast for this huge amount of primitives. So overall, this will of course depend on each tool. So this is the result that I got, but having a different tool, having more geometry can have even more impact. So it will definitely depend from tool to tool, but in this case, I got a pretty huge boost from just generating this portal. Now, as I also just mentioned something about proxy mesh, we can even go faster by enabling the proxy mesh feature. So I'm going to show you a clip of that. And you can already see that immediately, almost after 1 or 2 seconds, version 2 got updated, while version 1 is still on that 9 seconds. So again, putting them all together, so version 1 is still on that 9 seconds, version 2 is almost 3 seconds, and version 2 with proxy mesh is only 1 second now. So that's extremely fast compared to the other ones. So out of the box, version 2 will have just a significantly boost. But if you want even faster generation, you should be able to also enable proxy mesh to make that even faster. So some more information about proxy mesh. You should only use this for generating these versions. So when you're playing around with your tool and you just want to quickly see your different versions and interaction with sliders, you will use a proxy mesh. But the final output will never be a proxy mesh, but a static mesh. There are also some options that will automatically bake proxy mesh to a static mesh, so you don't have to worry about saving out proxy meshes. Now you might want to try this out for yourself, so I'm going to show you where to find these options. So we're going to go here to the Houdini engine menu, and in there we're going to go to plugin settings, and in plugin settings there is a toggle for proxy mesh generation. So once this is enabled, we will use now proxy mesh on all of our digital assets. So in that menu there are also even more settings. So for example, we can say that after 20 seconds it will auto bake to a static mesh, and so on. Also important to know is whenever you see a Houdini icon above your tools, that means that proxy mesh is currently in use. So know when you see the icon that this is a proxy mesh and not a normal static mesh. Now let's talk about instances. So there are two main things in here that I want to talk about, which is the instancing of actors and also a new, better way of referencing instances to a digital asset. Now first is directly instancing of actors. So once we open Unreal, we will often see this menu with all our actors, like a point light, cube, certain blocking volumes or other things. So we now can directly use the name in the menu, like point light, and use that in an instance. So for example, we can instance point lights. Now again, the way this is done is we use our Unreal instance, and in here we're just gonna say point light. And that's it, so this should already work. So there is no need to get a special path or reference to the point light placement in the files, we just say point light. Now next up here is then the better way of adding references. So we can now drag and drop models into a string value. So this will automatically get the path on where the bush is stored in this case. So before, we had to right click on the model, get the path, copy paste the path in the string, and then it will work. But now we can just drag and drop this. So let me look at an example. So here again, I can drag this and drop this in the string. And then we have this updated here. And that's as simple as it is. So this allows us to way easier add our custom models to specific instances of a digital asset. Now, if you want to try this out, we will open our digital asset menu and we will go here to a string parameter. And in there, at the bottom, there is something called the tags. And we will add a new tag called Unreal Ref. So whenever this is enabled on a string, that means that we are able to drag and drop our Unreal assets to a string parameter. Now next up is uProperty overrides. So this also works with instancing. So uProperty overrides, what is this more specifically, is that we can override Unreal properties or values. So we can control a Unreal value, like for example the color of a point light, or we can for example set a material. So here is an example of this. So I have my Houdini tool who is generating point lights in the scene, and in there I can for example control the color or the intensity. So as you can see in the Houdini tool I set a red color, and then in Unreal it will then also copy that red color as parameter there. So we have Houdini controlling Unreal parameters or values. So this allows us a new way of working, where in this case I can control the light color of each light I instance. Another example here is that, for example, we can set material. So we can set different materials on each instance. So this will help a lot when you're instancing a lot of, for example, here these crates, but you want some material variation in there so they don't look all the same. So in this case, sometimes they will have like this metal look, sometimes they will just have the normal look. Then you might be wondering on how to set this up. So again, this is driven by attributes. So a lot of these new features are driven by attributes. And we need to create a new attribute called Unreal uProperty, and then we want to say what property. So in this case, light color. So of course, this is referencing to, in this case, the light color from a point light. Then I'm going to set this to a type vector and give this the value of a red color. And this is how we can set and override uProperties. So this can be very useful if you want to, for example here, get spam lights with colors or set different materials. Then again here, we can also do it a bit more advanced and place down some wrangle nodes. So we can just here type in Unreal property for the intensity, give it a random value, and also here set uProperty for the light color and also give it a random value. So this opens some new possibilities, and for example this can be the beginning of generating some procedural lights in a scene, for example. Next up, I want to talk about the foliage systems. So Unreal itself has this nice foliage system where you can paint grass or remove grass with a brush. So Houdini has now a better way of working with that. So what we want to do is when we generate our foliage, we want it to have automatically added our grass to the foliage system. So here I have a tool that generates this foliage. So this is also foliage from the Quixel. And I want them to automatically be added to here, the foliage system. So by just adding an attribute, we can automatically add the grass to the Unreal foliage system. So there is also no need for baking. Once you assign this attribute, it will automatically add it to the foliage system. So here is the look on that. So I'm just gonna enable that attribute to add the foliage, and a few seconds later I can then here have my foliage layer. I can also here override this with the brush again, so I can manually remove or paint the grass here. So this opens some new ways of working, like we can procedurally generate the grass in our scene, and then we can manually override this with the brush tool, like remove parts, add more variation, and so on. Now, the setup of this is again driven by attributes. So we have this attribute called Unreal Foliage, and in there, once it's got the value 1, that means it will be able to add it to the foliage layer or system from Unreal. Next up, I want to talk about the input menu. So this is a quite special menu or important menu if you want to input things from Unreal Engine and send them to Houdini. So here we can input meshes, landscape, the new BSP brushes, and also digital assets. So here on the image, you can see that at the bottom there, at the current selected actors, we can, for example, input a box brush, a cube, and here 3 other different digital assets. So again, this is an important menu if you want to send, for example, the BSP brush to a Houdini tool. We also now have the ability of a bounce. So in this case, I set this green box, and everything in the green box will automatically be added as input. So we have this feature there called bounce selector. Then we say, of course, what is my bounce? So in this case, it's that green box. And everything in the green box is automatically added here to the current selected actors. So in this case, there are even other digital assets to show that this is possible. So again, we have a variety of different inputs that are possible. And then currently what you're seeing here is whatever the input is, my tool will copy whatever is in the green box. So again, if you have a situation where you need to select a lot of different models, we can just set a bounce. So you don't have to select them one by one, but just can create a bounce around these objects. What is also, for example, possible is with session sync, you can basically import big parts of your scene into Houdini. So you can set a bounce around your scene and then have a tool importing all these actors in the bounce. So you can then visually see in Houdini what are these models in the bounce. Then here is the other example of that building generator. So this is also again using the box brushes or the BSP brushes for input. So based on that BSP brush, the house is then generated. Now next up, let's talk about curves. So before we were able to also have editable curves in digital assets and so on. Now we also have the ability to output curves generated from a Houdini tool to an Unreal Spline component. So we have linear curves, closed curves, and so on. So let's take a look at the video of that. So here I have a digital asset. This is generating a curve. And I can still then also move around these points, as you can see. And once I'm happy with the result, I can press bake here. And this will now output a Unreal Spline component. So from our Houdini asset, we are outputting here a spline component, as you can see. So this can be so useful if you want to generate spline components or want to save out spline components from, for example, a fence tool and so on. Now again, this is driven by attributes. So whenever we use a attribute, which is called Unreal Out Curve, we will output a curve once you click on the bake button. You can also output linear and closed curve. So but by default, the Unreal Out Curve will just output the curve. So that was it for most of these features that I wanted to talk about. There are some more changes here and there, but these were the main features that I wanted to show you in this presentation. So you have a really good idea now of what to expect from the version 2. So if you're interested, definitely try them out. And what I also wanted to mention here is we have backwards compatibility. So currently you might be using a lot of V1 tools in your project. And with backwards compatibility, you will still be able to use those tools in a V2 project. So by default, the V1 components will be converted to a V2 assets. So we have some auto rebuild functions there. And also this can be turned on or off in the plugin settings. And I definitely want to mention that use this at your own risk. There are still a few issues here and there that are known that might cause issues. Feel free to let us know if you found any issues so we can look into that so the backwards compatibility works even better. Then the desert scene. So I've used this desert scene as a guidance to show off some of the features, like generating the world, the sci-fi portal, and so on. So this desert scene will soon have a tutorial. So if you're interested in how this was made from scratch, I will do a tutorial from this. And in this case, I'm gonna, for example, here start with generating the basic terrain. So we'll use the height fields of Houdini. I will add some masks for Unreal and so on. Now from there, I'm also going to scatter around some props. So I'm going to slice the terrain in multiple pieces. So in my case, I had a 4x4 terrain. So I will have 16 pieces. And I will place down here some cliffs, some rocks, some foliage, some palm trees, and so on. I will also manipulate the terrain so they, for example, nicely blend with the cliffs. Then furthermore, once we have the whole terrain and scattering setup, let's integrate that then in PGG as well. So again, I will generate the base terrain, calculate how many tiles I want, and then split and scatter each of these tiles. And finally, I'm going to use the Houdini engine to bring this nicely together. So as you could see here on that video, this will then be the end result. So we will bring on everything from Houdini to Unreal with the Houdini assets, from PGG to world composition, so everything is nicely set up, and you also have some default streaming like you can see here. And that was it for the presentation. So I hope you enjoyed it. I hope you are inspired to try out some of these new features, and thank you for watching.
All right, next up we've got Rob Stauffer. Hey, Rob.
Hey, Chris.
So give us a little background on yourself so people know who is Rob Stauffer.
Sure. So before joining SideFX in 2013, I worked in production for about 20 years. I started at Digital Domain in the 90s, late 90s, and went through Weta Digital, Asylum Visual Effects, Sony ImageWorks, and ended up at Rhythm & Hues for a while, and then left there in 2013 to join SideFX.
Right on. So what are you going to be talking about today?
Today, I'm going to go over some of those awesome features that everybody saw in the launch video for Solaris and what's new in 18.5 as far as Solaris is concerned.
Excellent. Well, let's get started.
Cool.
All right, so I have a real basic scene here. I just have one sublayer node that's bringing in everything. I have a couple of lights, just one environment light, dome light, and one sunlight. And as you can see from the render here, it's pretty dark, kind of flatly lit, and so we're gonna work on that a little bit too. And I have two cameras. So I'm gonna pop back over into GL. So you see here, we got a pretty nice representation of everything here in our GL viewport. There's a few things that we can do. I have a pretty good machine here, so things are moving around pretty well. But if you wanted to turn things on and off, there's a lot of ways that you can do that. We've covered in the past how you can just go right into your scene graph tree here and start turning things off that way. So here I can turn off all that stuff. I can go up and turn off the effects. Oh, that's the wrong one. And get us just that terrain and the market. Now you'll see here this middle icon is red. These are all my viewport overrides. I can say clear all viewport overrides. Another nice thing that I can do here is let's go back in and turn off all of those assets again. So let's turn off all the foliage, and I want to turn off all of the effects. And now I want to go over here and I want to say save viewport overrides. And I can call this market and terrain only. And so now I have that. You'll see this is now in this menu that I can say, oh, market and terrain only. And it brings back those viewport overrides. And of course, as usual, I can go in and say clear all viewport overrides to bring that stuff back. A nice new feature with Houdini 18.5 is we've added a new node called Loft Payload Info. And what that does, if you remember in the past, we have some control over here to turn off or unload all of the payloads in the viewport. So you see when I do that, everything goes away because in this case, everything is payloadable. So, I would have to go in, I could go in and say, all right, let's go to shop back, load those payloads. Let's go into shop front, load those payloads and start going through and turning things back on. But the downside is I don't see any representation of where everything else is in my scene. So with this loft payload info node, if I just put that into my network there, you'll see that it generates a bounding box for all of those payloads. So just a nice way to visualize what is not loaded into your scene with a bounding box. So it's something that was added with 18.5. Okay, so let me load back all of those payloads. And, oh, there we go. Took a minute. Another thing to point out is, in the viewport here, I have everything turned on. I can go into optimize here. I have my scene polygon limit set pretty high, so I'm going to turn this back down to something like 10 million, maybe 20 million. And that is going to, now, once I reach a certain polygon count, it's going to start turning things into bounding boxes like you see here. So for what we're about to do, I want to keep things pretty quick for the purpose of this demo. So I am going to go to my market and terrain only viewport override. So that's all I am seeing. And I'm going to start setting this up for sort of a multi-shot thing. So both of these cameras have some animation on them and it is sequential. So they don't each start at 1. This goes from 1 to 72 and this one goes from 72 to 240 or 248. Let's move that to 248. And so what I want to do now is I'm going to drop down a switch node at the bottom and plug in both of my cameras. And after that, I'm going to put down an edit context options node. So we've introduced context options with Solaris, and it's a nice way to, you probably have seen the context options editor as well, where I can go in here and add, string menus, integer menus, give it a value, as well as a little bit of a label. So it's a nice interface for selecting things. We can do the same thing on the edit context options node. And we have a tab here that's called time-based options. And what that will do is allow us to set a frame range for that particular value. So it'll be driven by where we are in the play bar. So that way, in this case, we have sequential camera animation so that we can scrub through. And the goal is to drive the switch by this context option. So I'm going to set the first one from 1 to 72, and I'm going to give it an option name called shot. And shot value, or the value, is going to be shot 01. Let me add another one, delete what's there. And we're going to say from 72 to 248, and that is shot as well, and it's going to be shot 02. Now, this shot, this option name is the variable that I want to plug into my switch. So if I go up here and I say backticks shot, it should work. And it doesn't. I get an error, and that error says unable to evaluate. Well, if we go back to our edit context options node here, you'll see that it's set to option type string. That's because that's what the value is. And this is looking for a number. It's a typical switch lop. So I'm going to switch this over to by name, and I'm going to plug that back in here like this. And I still am having a problem. And the reason for that is you'll see that the input name is using the input name default, which is whatever is being fed into that switch lop. And there's a couple of ways to remedy that. The first way is, or I think is the best way to do it, is to actually put down a null. And let's call this shot 01. And so now it's fine. So now that is the switch lop is setting that. You'll see it now says shot 01. That's what it's using as the name. So when it finds that value, it sets it to that name in the switch. So now I'm looking at shot 1 because that's where I am. So you'll see here in our network view that is the active connection. Another way that we could do it is actually go in here and say, well, I can rename it right here. And so now let's see if that works. So if I go past frame 4 to 72, you'll see that it's now looking at this side. So I don't recommend doing it that way. I think that for cleanliness and sort of organizational purposes, the null is the way to go. So let's all drag that over. So now I have a shot 02, and I can actually go back inside here and just delete what I put in there. And so it's sort of back to normal. So now that I've done that, I want to, the problem now is that this is great. I'm switching between the shots. It's switching between which sort of tree or which branch I'm looking at in my node lop network, but nothing's changing in the viewport. In fact, if I look at a camera, the moment I go to the next branch, it breaks because that camera is no longer there. So what I want to do to fix that is I am going to drop down a render settings node and put that before the null. Now it's important to see here that so the primitive path is set to render and then $OS, which is calling on the name of that node. So I want to change where it says $OS to render settings. And I want to go down here and where it says camera, if I control click on the arrow, it brings up my little select primitives menu and I can select shot cam 1. And what this is doing is it is storing a primitive called render settings. In fact, you can see it in the scene graph tree here. And that's where Hydra, or when you render, that's what it looks for any sort of render settings, as well as the camera, resolution, any AOVs, anything like that that pertains to your render. So what I want to do is I want to have one of these for each of the shots. So what I'm going to do in my camera field here is put a backtick, op digits, and then. So what this little expression is doing is actually, if I middle click on camera, you see it's resolving or it's evaluating the digit that is on the node that the expression lives on. So when I alt and drag this, it actually now says shot cam 2 because this is render settings 2. So it's a quick little cheat. If you have to make a bunch of nodes and it can be driven by the digit of the node, then it's an easy little thing to do. Nice little thing to do. Okay, so now that I have a render settings camera, so that means there's camera information stored on the render settings. If I click on render settings in my scene graph tree, you'll see in my scene graph details, there's camera shot cam 2. So that means that the current state of the scene graph tree there has a render settings primitive that has shot camera information. Now, I'm displaying from this edit context options down here, and I can go up here, and now there's an option in your viewport to say render settings camera instead of explicitly setting the camera. So what's nice about that is all it does is look at that primitive and set the viewport to whatever the camera is set to on those render settings. So as I drag through, I can switch between cameras. Okay, so now that I have that sort of set up, there's a few other things that I want to do. So I want to start messing with the lights. So I have these sequence lights here, and what I want to do first is I'm going to drop down a collection node. And what the collection node is going to do, what I'm going to use this for, is to put these two sequence lights into a collection that we will call sequence lights. And let's call this sequence lights. And I want it to, there's only those two lights in the scene, so I can just say all light primitives are going into this collection. And if I open up under my scene graph tree here, you see this little window closed. You'll see collections, you'll see sequence lights. In fact, if I click on the arrow here to select anything in there, you see it's selecting those sequence lights. So, so I know that that worked. So now I have a collection in my scene graph that is called sequence lights that contains those two lights. So we have a nice little workflow here for switching between shots. but I want to work as much as I can in the viewport. And so one of the things is if anybody has worked in the viewport before and you want to drop down a node, so you're in your viewport here, and you hit tab and you drop down a light, and hit enter, it puts it at the end of the network. So it's basically looking for whatever I have selected, and it says, well, that's where the next node is going to go. And that's what it did here. It dropped down a light. If I was over here and I had this null selected and I did the same thing and I dropped down a light, it's going to put it right after that. Well, I don't always want to do that, and I don't want to have to move around each time that I want to work on that. I want to, when I'm working in the viewport, I might want to add lights or certain things in particular spots in my LOP network. So what I can do is we have these things called insertion points now. So I'm going to put one at the bottom here of my sequence lighting, and I can give this any name I want. I'm going to call this sequence lighting. And you see now in my viewport, I have a new menu that popped up that's called for the insertion points. And it's right now it's sequence lighting. And so what that does is when I select one of these, it will say that is where any node that you add in the viewport is going to go. So even if I'm displayed from down here, so let's say I have that and that was the last thing I did. I have edit context options, but I have sequence lighting selected as my insertion point, and I hit tab light. It drops it above that. So it makes it a little bit easier to be hopping around your network view while you're working. So I want to add 2 more of these. So let's tab insertion point, put one here. And this one I'm going to call shot lighting. And I'm actually going to drag and copy this one as well. And I'm going to leave them with the same name. They both can be shot lighting. So now instead of, you might think, well, why is that not shot 01 lighting and shot 02 lighting and shot 03 lighting and so on? Well, because I don't want to do that. I don't want to have all these different menus of like shot lighting, especially because I'm working on a multi-shot situation and I want it to just choose whatever the current shot is that I'm looking at. So we've already set up our context options to switch based on where we are in the timeline. So what I can do here is instead of seeing all of my insertion points, I can just go, show me the ones that are in the current cook path. So what that means now, so my current cook path is on the left here. So if I go shot lighting and then hit tab light, there it is. It goes right above that insertion point. If I scrub along and I go to my next shot and I do the same thing, then it goes above that one. So now it makes it a little bit easier to know that, or be confident that whatever you're looking at in the viewport, that is where anything you add in the viewport is going to go based on your insertion point as well as your context options. The other thing too, we have all these radial menus over here, and by default, the default radial menu is main, and that means that when you hit C, that's the one that pops up. You see we have model, crowds, all these different options for you, and you can change that. You can go down to utility, and you see that we have a radial menu for insertion points. So now those insertion points dynamically show up here. So if you added a bunch more for other things, they would show up here. So you could just say shot lighting and then hit tab light. And then again, I could say sequence lighting and hit tab light. And you see it's putting them all in the appropriate location. So again, these are just little sort of interactive tools that we've added to try and help you navigate your network and try to create a more seamless workflow between the viewport and the network so that you don't add a bunch of things in your viewport and you look at your network and you're like, oh, that's not where I wanted it, or it's a mess now. So hopefully that will help quite a bit. The other thing that we can do too is, let me add a light mixer on shot 1 over here. So let me just put it right here. Make sure that I'm looking at shot 1 in the viewport. So you see, I already see my collection of my sequence lights. And of course I can drag over that whole folder and expand it, and I have all of those lights in there. Now I want to add another light. So I can do that also from my light mixer panel. So if I just go up here and I say, let's insert a point light, I get a parameter window that pops up, and I'm going to change it into a spotlight. Let's just give it some softness. And I want to drag that over to the mixer as well. So now I can start just kind of changing the values of that spotlight. Well, I'm not seeing anything. So let me solo the light for now. Actually, turn that off. I don't want to solo it yet. I want to make sure it's selected over here, or that I've selected that light. And now I'm going to, in the viewport, what I want to do is I want to interactively place this light in the viewport using some of our handy lighting tools. So if I hit H, it shows me all of the different controls I have to the different modes that you have when you're placing lights. So you'll see that Shift S is specular, Shift D is diffuse, and Shift F is shadow. So if I hit Shift F, it also changes up here. So I easily could click on these little buttons up here too, but I want to stick with shadow. And now what I want to do is if I click on this table, that's the pivot point for where the shadow is going to hit the ground. So I click there as the pivot point for that point light or that spotlight. And then if I shift click and place my target, that's going to place that right there. Now it's super close. It's not doing what I want. So I want to move it away. So if I control drag, it's going to move that light away for me. So I'm getting a better spotlight there. Now you'll notice over here that the intensity has gone up way up. And that's because as I move the light away, it wants to make sure that the table, everything around it is getting the same sort of intensity, the same light value every time. So if it moves away, that means I have to increase that intensity. Now I could lock it if I wanted to. Let me bring it a lot closer and then keep brightness. So that way, as I move away, you'll see that it's losing some of that intensity because there's some fall off there. So it's now, and then I can turn some of this back up. Here, there we go, and then move it away. All right, so now it's sort of hopefully not as flat as it was before. And you'll also notice in here too that I have now, there's a subnet. So as I create lights, instead of having, let's say you started creating a bunch of lights, you made it 5, 6, 7 lights, and you would have all these individual light nodes stacked up, and your node graph or your network view would be a mess. So what we're doing now is as you create new lights from the light mixer, we create a subnetwork and they all get dropped in there. So in fact, if I was just to create another point light here, I can go over here and say, insert point light. We'll call this, I don't know, point light B. And now you'll see it just puts it in here. So it keeps things a little bit cleaner. You also notice with a subnetwork here, we don't need the display flag like we did before. Okay, so I think that's sort of the gist of it. There's lots of other great new controls on the light mixer. I know Scott talked about it a bit in the launch video. Again, the spreadsheet view is still here. We can go in here and start messing with, actually, let's take this light, drag it over, and I don't want to use this at all. And then this point light, let's give it a little bit of color, something like that. And then maybe the environment light gets a little bit of blue, something like that. And okay, so it's shaping up a little bit. And again, I can scrub through. Let's make sure I'm set to render settings camera. Okay, so now that I have some lighting set up, let's go over here and just for fun, let's make sure that I am in shot 2, and let's go to shot lighting and add a light here. And we can make this also a spotlight. And then maybe this one will be Shift F, click there and there, and let's move that up, and that'll be a little bit more top down. I can add a light mixer. Let's put that right after that. And let's just drag light 1 over here and give it a little bit of a blue context. And also, actually, let's bring these down. So, these are in a group, they're in a collection, and I can just bring the whole thing down like that. And then in the meantime, bring all of this up like that. And again, let's go back to make sure that we're looking. So now we're getting two different things. Okay, so this is really a really basic setup for doing some multi-shot workflow. So now that I have a couple of things set up, I have a couple of light setups here. What I want to do is maybe do some test renders. So we've introduced this new render gallery. So there's a little hard to see. You can pop it open here. So if I just click on that, this pops open. And I am going to look through my camera and hop on over to Karma. And let's get a render. All right, so there's a quick little render of shot one. So now I want to do some testing on this. So let me just add, I'm just gonna take a snapshot of that. So now I have one image here. Let me make sure this is set to the right resolution. There we go, much better. Let's grab that. All right, so I have one image that I like. I'm like, okay, that's not so bad. Let me go back into my light mixer here and let me mess with the sun a little. Doesn't look like we're seeing that much. I can go back. Well, actually, let me just use my point light. So you see here that the f-stop value is kind of at the top. So I can go up here and change that top value so that I have more room to mess with it. So I can start to bring that up and maybe change this a little bit. Maybe let's add some green. Don't judge me on this. This is just to prove a point. Okay, so now I have another variation of the lighting, and I can hit plus and add that to the render gallery, and I can keep going and going. I can star the ones that I like by clicking on the stars. The other nice thing that I can do is I can open up my render gallery. You may not have it split like this in your desktop. This is something I added. Let me close it down here, and I want to set this to A and this to B. And so now you see you can turn on, if you right click in your render gallery view and have diff selected, now I can slide between the two and see the differences in the lighting. So let's say, okay, I actually still like that first one that I did a little bit better. So I can click on that and say right click, revert network to this snapshot. So keep an eye on the light mixer. And so, oh, it went away. So all the values went back to those original values that I had used for that. So what that's doing is it's storing a snapshot of what all the values were for your lights at that time and goes back to that. Okay, so the next thing I want to do is we have added Cryptomat support with Houdini 18.5 and Karma. So let's go over how to set that up quickly. So first thing I want to do is drop down an attribute wrangle, and I'm doing this because, I want to use the prim name for this, and I can't set a constant array with a variable in it. So I couldn't set, this is a constant array that I'm going to use to do this, and I can't just say @prim name. So what I'm going to do is create this string array called temp, and we will set it to, we will push temp, and we'll do, let's put @prim name, and then prim vars, we'll call it crypto, and we'll say that's equal to temp. Okay, and we want to make sure up here that right now it's looking at render settings, because that's the last thing that was fed into that, which is not, we need to set this to something in the scene. So let's say /scene, let's do shop. We can actually do shop star and then star. So that way it's going to take, if we had just stopped at shop star, then it would, or shop back, then it would just take shop back and shop front and group everything in that as one value. But I want to take everything, all the descendants of that, the immediate descendants of each one of those. So that is what this is doing here. So now if I drop down a Karma node like this, and let's turn down these pixel samples so it goes fast. Let's go to image output, and on AOVs, I have beauty turned on. Let's turn on normals, and let's turn on just for fun, just so you can see that. And then render extra render vars. And so here we'll call this Cryptomat. This is the name, how it's going to show up in your file, and it is a 3 float color. So these are both set to 3 float color. And the source name, I believe it was crypto we called it. And we want to set the source type to primvar and check Cryptomat. So now if I hop back over to Karma here. All right, there is my render. And then if I go here, there's my Cryptomat. Okay, so those are some of the highlights, just a deeper look at some of what we saw in the launch video. There's lots of other great stuff on there. If you go to the What's New section of 18.5 on our website, you can see some of the other great stuff in Solaris as well as the rest of Houdini. So I hope you enjoyed, and more to come. Thanks for watching.
All right, next up we've got Paul Lemeshko. Hey, Paul.
Hi, Chris.
So give us a little background on yourself.
I'm Toronto-based FX professional with over 17 years of experience in VFX, animation, and game dev industries. And I had pleasure to switch completely from Maya to Houdini in 2014. And to be honest, I have no regrets so far.
So what's today's presentation going to be about?
My presentation is about the PDG Shotgun Publisher tool, which would help artists to render CG assets with multiple light tricks and publish to Shotgun.
Excellent. Well, let's get started.
Hey everyone, my name is Paul, and today I would like to talk about a Houdini digital asset that I've been working on lately, called PDG Asset Publish. Let's say we have the asset that appears in different lighting conditions on the show, and our production process for each light trick involves rendering the asset, converting the result into video, and publishing to a project management software like Shotgun for review. You may know there are many production management tools on the market, but Shotgun is pretty much the industry standard. Thanks to Procedural Dependency Graph, or PDG, we can automate this process locally or on the farm without tedious coding. So here is the PDG Asset Publish. I'm gonna do a quick overview first and show you the example after. The UI contains the Cook Controls and Tabs section. In the Scheduler tab, you can choose what scheduler to use with all the settings. Currently there are 2 available, Local and HQ. In the Lighting tab, you can specify the path to one or multiple light rigs, and optionally the path to the HDRI or image that represents the HDRI from the light rig. This image will be used later for compositing purposes. In the Render tab, you can choose the render engine and adjust the render settings. Currently we have OpenGL, Mantra and Karma. All the engines except Mantra can render lobs. The other tabs are optional and can be enabled from the Cook Controls by toggles. In the Com tab you can enable frame timecode, also HDRI that you previously specified in the Lighting tab, plus Gray and Chrome Balls overlay if you render lobs. In the Video tab we can change some FFmpeg settings, and in the Shotgun tab the Shotgun related settings. I'll be using this spaceship asset example to clarify things up. It's a turntable with 4 light rigs: day, overcast, sunset, and night. Each light rig is located in its own subnet and defined by the subnet's name. As you could see, the PDG asset publish is a SOP level HDA. We are gonna use the local scheduler to test it, and 1 light rig for now, sunset for example. In the render tab we will be using OpenGL, and as you may know, it's a GPU render. We have to specify the asset with global path. Frame range, I like the frame 25 and the camera path is correct. I'm okay with the output file image name. Just keep in mind that the render type and light rig names will be added to the file base name. In this case, I expect to see beauty_OpenGL_sunset.0025.exr. In the display options, I would change the anti-alias to something more reasonable. More light samples, ambient occlusion, reflection, and click cook. Okay, it's ready. In the render folder, as we can see, the image file with output image base name plus render type name and light rig name. Let's add the frame code text at the bottom of our render and the light rig HDRI icon at the left top corner. To do that, we have to set the image file path under the lighting tab. Also enable the compositing tab and make sure that the frames and HDRI icon are enabled. In the frames tab we can change font type, text, and text size. In the HDRI tab, padding, image fraction, it means from the actual render frame resolution. Also font type and the size of the image file name text that will be shown at the bottom of the icon. The output file name will be comp plus render type and the light rig name. Click cook and only the compositing operations will be calculated. Okay, done. And as you can see, a new image file has been generated with the frame code and HDRI. I'm pretty happy with the result and I think it's time to render all the frames and convert to video. Let's jump into render tab, and in this case all frames in one batch must be enabled. Otherwise all the frames will run concurrently and this may hang Houdini or your system. Plus, it's not recommended to run multiple frames in parallel with GL anyways. Also, we have to enable the video tab and make sure that FFmpeg has been installed. You can download it from the ffmpeg.org website. Download, Windows, release. After downloading, you can unpack and put all 3 executables into C Windows System32 folder. It has to be done if the FFmpeg binary parameter is set to system path. In this example, we are gonna use a custom path to the binary files. Click cook and the video file will be generated. Here is the video file. Okay, cool. It's time to submit this file to the Shotgun. But to make it work, we have to download the Shotgun API from this website. Then unpack it and copy shotgun_API 3 folder to Python 27 lib site packages located in the Houdini installation folder. Okay, we're all set. Now we have to enable the shotgun tab, and I'm using a JSON file to access my project page. Also, we can choose to use the login and password, but it's not recommended due to potential exposure of your credentials in the environment. It can be a security risk. This is my shotgun page, and my project name is PDG Demo. The asset name is ship, and the version name is ship v1. Let's click Cook. Alright, we've got the asset published to the shotgun. Let's check this out. My page, PDG Demo, assets, ship, ship v1, plus OpenGL, and the Lightrix name Sunset has been added to the version name. Beautiful. Let's publish all the Lightrix simultaneously. In the render tab, we switch source to lobs and specify the ship lob network path. This is how it looks. All the Lightrix are under the lights primitive, and each of them is located under its own unique name. I would like to overwrite the existing files by switching the cache mode to write files. It would make sense to set frame per batch to 25 to avoid overhead, since GL renders are generally fast. Camera and render settings are fine. Same in the comp tab. As you could see, we've got the additional tab called Balls, which enables the gray and chrome ball overlay on the right top corner of the rendered image. This is only accessible when rendering lobs. We can copy camera rotation and paste it into rotate camera parameter to match the camera angle. In the video tab, we are switching to write files, and the shotgun tab we have to enable version only. This will publish all the clips to the ship asset if it exists. Scheduler tab. If we use local, we have to enable single in the job arms to avoid rendering all the Lightrix in parallel. But I like to use HQ scheduler to utilize my home farm. We have to specify the HQ server address with a default TCP port of 5000. And in the job arms tab, tags set to single. This means that each machine can run only one job. It's critical with GL, otherwise we may get VRAM overflows. In the lighting tab, we add 3 more Lightrix and change the name to lob style path. Also copy-paste the HDRI path. Click Cook. Okay, as we can see, it's all in the shotgun now. Awesome, it's karma time. We can remove the single tag. The number of the concurrent jobs that each machine can run, we can control with the CPUs per job and Houdini max threads parameters. But in my case, I have these settings set per each machine in its hqnode.ini file. You can learn more about it in the Houdini docs. In the render tab, we switch to karma. The lob path is correct. 10 frames per batch. Camera and render settings are fine. We can override that render settings with the settings from the lob network by enabling the render settings prim parameter and defining the render settings primitive from the lob network. Comp, video, and shotgun settings are fine, and click Cook. And we can monitor the rendering process with HQ web service. Okay, it's done. Let's check the shotgun. I think it's looking good. Same thing with Mantra. We need to change in the lighting tab the path for each light rig to OBJ, and in the render tab choose Mantra and the candidate object. Render settings are fine, and click Cook. Let's check the shotgun page. Alright, it's looking good. Okay, it's time to dive into HDA and check what's inside. This wage generates the tasks based on the number of the light rigs. The Python script isolates the HDRI and light rig names from the path. The attribute create generates the render attribute based on the selected render type. These nodes create important attributes like camera and frame range. The wedge node generates tasks for the chrome and gray balls, plus related attributes. These nodes are responsible for the rendering tasks, and these nodes combine balls output with actual render results per each light rig. Here is the compositing part. After that we have the video encoding, and then the shotgun polishing. It's important to note, if we already have rendered files on disk and cache mode in the render tab is set to automatic, the PDG won't overwrite the existing files even if we change the render settings. This is true for all the render types as well as comp and video tabs. This issue will probably be addressed in future builds of Houdini, but for now we can use the write files cache mode. Also, it's worth to note that the ship in Lobs GL looks different from the standard GL viewport. Let's compare it using a memory toolbar. And as you can see, it's much noisier and more reflective than the standard GL viewport. This is happening because of the USD preview shader doesn't support specular roughness texture in the Lobs GL viewport, and whole surface gets specular roughness value of 1. Currently there is no fix for it. Another issue that we may see is when the glass disappears in the GL viewport if we switch the transparency from low to medium or high quality in the display options. But it looks fine in headlight mode. To fix this, we have to set the transparency of the shader to 0.99 instead of 1. And it's fine now. There are a few new PDG features that are worth mentioning. In the performance monitor, we can see more detailed TOPS feedback than before. Also, the collapse and show log summary. The last one is handy for troubleshooting things. The asset is open for an expansion. It's pretty easy to add other hider render delegates. Here's an example for Peerman integration. It's just a matter of dropping the render settings node over here and promoting its parameters to the HDA UI under the render tab, plus adding a menu item to the type parameter, and make sure that the render name is exactly the same as we would see in the drop-down menu of the other delegate parameter on the USD render node. And the last step is to add the render delegate name to the attribute create node render parameter, like that. Also, there is a possibility to add deadline and tractor render schedulers to the asset. This can be done by dropping the render scheduler node and promoting the attributes to the scheduler UI tab over here, and adding the name of the node to the drop-down menu of the top scheduler parameter. The name of the deadline scheduler node should match the token value of the menu item. Alright, this is pretty much it. So I hope this presentation helps to understand how useful and powerful PDG is in automation of the everyday CG production tasks. I would like to thank all the amazing SideFX developers for making this little project possible. And special thanks to Fiona Wong for giving me this opportunity. I hope this tool will make your life more productive and efficient than before. Feel free to contact me if you have any issues or questions related to the HDA at pdg.asset.publish@gmail.com. Enjoy and happy asset publishing!